It's convention that because we're being televised, we're not allowed to start early, so wait for. Good morning and welcome. Thank you very much for coming in. Could we start by looking at the changes in the conclusions of Working Group 1 for the fifth assessment report compared with the previous assessment reports? Just like to highlight what the main changes are and why they've been made.
Shall I start with a general comment, perhaps? I mean, I think the first thing to say is that after more years of research and more years of observations, there's not a huge change in the conclusions of the AR5 report on the science compared with the previous reports. So there's a fair consistency through there. It really builds on those, and there are some little bits that perhaps emphasise more and some slightly less. I mean, I think if I was to pick out one thing that actually impressed me as new, and I'm sure others will pick out others, but the fact for the first time we can really measure the decrease in the ice sheets in Greenland and Antarctica and see their contribution to sea level. So the present 3 millimetres per year rise in sea level, about a third of that due to the decrease in the Greenland and Antarctic ice sheets. This had been expected that it would be there, but it can now be measured from satellites, and I've found that particularly impressive. As I say, other things have gone up and down, but I think the main thing, there is a continued message that, and a stronger message that we can see the changes in the climate system that are consistent with the increase in greenhouse gases that we can also see, and understandings have increased and models have become more complex, but still the same sort of conclusions ride through as were there in the previous reports.
Yeah, I think that's right. If you look across the report, you'll see a further evidence to support the conclusion that warming is unequivocal, and then we have more evidence from right across the climate system of the effects of human influence on the observed changes, and that's not just in temperatures of the atmosphere, it's also in temperatures of the ocean, it's in reductions in snow and ice, it's in rising sea level, and it's in changes in some climate extremes. So we have more evidence that strengthens that assessment on human influence on climate. And then we also have new evidence around the future, the conclusion that continued emissions of greenhouse gases will cause further warming, further changes in the climate system. That limiting climate change will require substantial and sustained reductions of greenhouse gas emissions, and we have new science that shows this link between overall cumulative emissions and the overall warming of the climate system.
I agree with all that. I think one of the really interesting developments which has emerged is actually how strong consensus is both within and outside the IPCC on the science now. I think it's, reading through the submissions to this inquiry, it's easy to get the impression that there's still lots and lots of disagreement, but it is interesting that it is important to remember that the things we do disagree, we do agree on, and by and large, the projections of the where the IPCC's critics have made projections, they're now sort of at the bottom end of the IPCC's own ranges. There are other people who make projections which are at the top end of the IPCC's ranges. That's why the IPCC gives uncertainty ranges. But that's a very different situation to where we were back in the 90s, where we actually had people saying that they were an order of magnitude different from the IPCC's predictions. We're now essentially talking about a range of uncertainty and some argument. Obviously, there should be some argument about where we are within that range of uncertainty. That's what the range of uncertainty is for. So I'd happily go into that in more detail as we proceed. But I think that's actually a really interesting development, that we're seeing such a high level of agreement on the big picture of the amount of warming we should expect over the coming century.
Do you think, in the light of those answers, that there are some areas of climate science which could now be considered to be settled?
Well, I should probably respond to that, because it sounds like it's a response to obviously no aspect of science is finally settled in the sense there's no more uncertainty about it. On the other hand, the disagreements about the size of the climate response are typically at the level of maybe 20-30% or so, and you should bear in mind that a 30% reduction in the transient climate response, the warming we expect by a given date, means that the warming you might expect between now and 2050 might take until the early 2060s instead. I mean, that sort of level of disagreement doesn't really, I would imagine, make a huge amount of difference to the kind of decisions we have to make. So, I mean, while there remains uncertainty and scope for continued progress in the science, it's important to keep the uncertainties in context.
Just to give an analogy, many people would have thought Newton's laws, etc., that was all settled, but along came Einstein. But for most of us, Newton's laws are a good enough approximation. So settled means within a range. We think we know where we are, but it's not. We know exactly where we are.
Do you have any anxiety that controversies which arose from previous reports, take the hockey stick graph, which seems to be referred to quite frequently, do you have any anxieties that those sort of controversies may cast doubt on the conclusions reached in AR5?
I think there is a concern always if previous mistakes that have been made, or as in some cases, or maybe accentuation of one view, and it's a group of people and mistakes will be made, and that should not reflect on anything in the future for that body. Of course, we should all be sceptical, and we are all sceptical the whole time, so probing it must go on, and it's not going to be taken as the Bible, but it should be taken as the view of a large group of scientists from a diverse range of where those scientists come from, and this is the consensus view given by them, and that's what it is. There must always be concern if then people can return to a mistake made 20 years ago or an accentuation made 20 years ago to down excellent work that's been done now. There must be a concern.
And the other important point to stress is that it's very easy to think, looking at the very elaborate process involved in reviewing and assessing these IPCC reports, to think that the strength of the evidence lies in the process of the report, and therefore sort of you can find any piece of grey literature used, therefore the process is undermined and the evidence is undermined. That's not how science works. The strength of the evidence lies, with respect, it doesn't even rest with the number of FRSs of the people presenting it. And I'm only jealous there, but it rests in the fact that the results are reproducible. In fact, these are. If you want to explain what we've observed over the past century, it's very difficult to construct a climate model which does not warm. In fact, nobody has yet constructed a climate model which explains what we've observed over the past century and doesn't warm substantially over the coming century under a continued sustained increase in greenhouse gas scenario. In fact, sort of just to really illustrate this point, I hope you'll forgive me, I did send in as some supplementary information the little 2-time constant climate model that the IPCC uses, and I'd really encourage committee members, if it's Excel spreadsheet, it's easy to do, put in some numbers, see how you can explain the data, and see whether or not your results differ from those of the IPCC's, and you'll find it's very hard to plug numbers into that model and not get results out that are broadly consistent with the IPCC projections. So it's ultimately, it's the data that speaks for itself.
Just following up on that point, and I think it's important to put the paleo information in context. The IPCC assessment is based on multiple lines of evidence looking right across the climate system, from the instrumental data that we have, from warming of the ocean, from changes in the water cycle, from all this wealth of evidence, sea level rise, all this wealth of evidence builds into this picture and robust, comprehensive assessment, as I say, based on multiple lines of evidence, of which the paleo reconstructions, with of course, the uncertainties that are involved with, inferring global temperatures from indirect proxies of temperature, play their part, but a relatively small part in the overall assessment, which is based on our understanding, on our climate models, and on the observational evidence.
I mean, these are quite complex issues, certainly for people like us, and they're dealt with at some considerable length in the report. I think it would be unlikely that any, or many, perhaps I can't speak for many members of Parliament would get beyond reading the summary for policymakers. Are there any risks in that you're condensing a great deal of written material into something which is of a manageable length for people whose this is not their exclusive preoccupation? Are there any concerns about relying on the summary actually for policy making?
As somebody who was at the plenary meeting for when the Working Group 1 summary for policymakers was approved, I think it's important to stress and for people to understand that those statements in the summary for policymakers are traceable back into the report. So there are clear lines of sight that go from those summary for policymaker statements down into the wealth of evidence and the depth of evidence that's in there. And indeed, that's sort of that's the really crucial part of the process in which we are inducted as lead authors to see that through. So of course it is a condensation for the main conclusions of the assessment, the main policy relevant conclusions from that. But each of those statements is then traced through to the underlying evidence, which then people can trace that back into the peer-reviewed literature. So as part of that process, that underpins that development of that summary document.
And what's stressing the scientific community is its own best guarantor of the probity of that process. I was part of the sort of internal discussion group which made the decision to lower the lower bound on climate sensitivity, which made a lot of noise at the time. And I've had a lot of feedback from colleagues in the scientific community about whether or not that conclusion was justified. And papers have come out since the IPCC report which point to substantially higher values for the climate sensitivity. And people invariably send me emails saying, see, when these papers come out. I mean, and that's the process at work. That's, scientists continue to check what other scientists have done, and obviously high-profile statements such as those made in the IPCC summaries are checked even more carefully than others, so that they get a lot of scrutiny.
Perhaps I could say the traceability of this and the review of it, of the whole process, I suspect members of Parliament can be more content over what goes on in this case than, say, much of the information they get in the economic sphere, I suspect, where they would read the summary but not know the details, and the traceability will be rather less.
Okay, John.
Yes. Gentlemen, I want to talk about sort of climate sensitivity and natural variability. Remembering that I'm just an ordinary layperson, it would be excellent if you could speak in language I understand, and I'm sure that will apply to a lot of my colleagues. Having said that, I always have this feeling that scientists are a bit like politicians. If you get two of them together, they'll both argue with each other just to be different. I just wonder if sometimes the science itself and the arguments we have, and I'm going to quote some people in a minute, it's done just for the sake of argument rather than when we're dealing with the facts as they should be. I could be wrong. You can comment on that when you make your question. Let me ask the first question then. The range of values quoted by the IPCC for the climate sensitivity parameter is quite large, between 1 degree centigrade and -6, or 6 should I say. Given the importance of climate sensitivity for predicting the future changes, have the IPCC failed to adequately address this issue?
I mean, I'm happy to start speaking to that because I was involved in all of this. The first thing to emphasise is you're absolutely right. A lot of the discussion about climate sensitivity is precisely because it's very hard to resolve. And it's actually not nearly as important a property of the climate system as the transient climate response, which I mentioned earlier. The transient climate response, forgive the jargon here, is basically the warming you get when you reach double CO2. The climate sensitivity is the warming you get when you get to double CO2, and then you hold concentrations there forever, and the definition does mean forever, and see what warming you eventually end up at. And as you might imagine, therefore, a sort of infinite prediction, which is the climate sensitivity prediction, is much more intrinsically uncertain than the prediction of the transient response. So a lot of the controversy, and certainly all the statistical controversies about statistical methods, revolve around this parameter that actually doesn't matter very much, because there are other things that we know better than that. But of course, in fact, it's climate sensitivity. It's a bit of a sort of Katie Price of climate parameters, in the sense that everybody talks about it because everybody else talks about it, but nobody can quite remember why we're talking about it in the first place.
Sometimes whether it's to do with the fact that people understand temperature rather than anything else.
Well, the transient response is temperature, but it's temperature by a given time. That's the point. It's sort of temperature over a finite timescale. The problems arise with pinning down climate sensitivity precisely because it's this very long-term equilibrium warming, which is very difficult to pin down with the things we can observe today.
So why does it take so much prominence?
Well, it's the job of the IPCC to assess the literature, and there's a lot of literature on estimating climate sensitivity. We also, devoted space to estimating the TCR. We emphasised in AR5 that the transient climate response is the more policy relevant variable. But there's a certain inertia, obviously, in the climate community. People are responding to other papers which have looked at climate sensitivity, and so it remains it remains a bit of an industry of people trying to pin it down.
Yeah, there's been some studies. What have we got? Foster's, Masters, Lewis, who have brought out papers, and but after the conclusions that IPCC made in 2013, is it perhaps a time to go back and look again at this, or is it just one of these things that will evolve through time?
I don't think there's any pattern of results published after. I think that several of the papers you mentioned were assessed in the IPCC assessment, but there's no clear pattern of results after the deadline pointing towards lower or higher sensitivities than results published before the deadline.
In fact, there was a recent paper that suggested that the models with the higher response were actually more in tune with the observations of clouds. So there's results, this is living science, and there's results that will come out. Almost all of them are within the range of the IPCC, but they're sometimes emphasising the one end and sometimes the other end. So there's no point of saying this is the crucial parameter, we must reassess it because there's new information that really pushes us to one end. This is living science, this is one parameter of a number of ways of looking at the climate system.
Yeah, Professor Lindzen suggested that an inaccurate appraisal of the role of aerosols in the atmosphere, these models used to estimate climate sensitivity, open to fudging. How severely do poorly understood climate factors reduce the reliability of climate sensitive estimates? I say that simply because aerosols are one of the things that the general public could latch onto because they all had them or have them.
So the assessment takes account of the uncertainty in the aerosols and includes it in our attribution estimates and in estimates of climate sensitivity. It is part of this assessment process I'm talking about, where we've looked at multiple lines of evidence, where we've looked at the processes involved, and we've looked at how well those processes are included in the climate models, which have improved considerably in the current generation in terms of how they represent these processes than the previous generation of models.
Did we overreact years ago about aerosols? Did we overreact about the effect they were having?
Well, we've known for a while that it's not just simply a matter of increasing greenhouse gases in the atmosphere, producing a warming, that there is potentially some effect from aerosols, notably a net cooling effect. That is not new in the AR5, but in the fifth assessment report we have provided ranges of likely warming since the mid-20th century attributable to the greenhouse gases on the one hand, and attributable to these other anthropogenic effects which indicate there's a net cooling effect. In other words, the overall warming effect would have been larger than observed were it not for some cooling effect from the aerosols. And that's all factored into the assessment, including of climate sensitivity and transient climate response.
Perhaps I can just say about aerosols, these are little particles, and the question is how much of those is in the atmosphere. They're all different sorts and they have different impacts. So it has been a living science area again to try and get measurements to show what is there and to actually see what their effect is. So the estimates change as we go through, but for many years there's been clearly the idea of the greenhouse gases tended to warm, but these particles on average tended to cool, but it's on average, and that's difficult to say just how much that average is.
Okay. Now this I'm not altogether certain I understand the question, so hopefully you'll explain it to me. The doctors Curry and Wyatt have proposed a stadium wave theory that, contrary to the conclusions of the IPCC, suggests that natural internal variability has a larger role to play in climate change than does anthropogenic CO2. What impact does the stadium wave theory have on the conclusions of the IPCC?
It's basically... So this is the issue of natural internal variability, as we call about it. Yes, so we talk about natural internal variability, which is internally generated variations in the climate system. I mean, one example of that would be the El Niño southern oscillation, but there are others like the Pacific decadal oscillation, which is what we call a multi-decadal scale type of variability, and that means that the temperatures can warm and cool globally on several decade timescales potentially, and that's not due to the additional greenhouse gases that we put into the atmosphere. That's a natural process. So we've understood this fact for a long time, and we've taken this fully into account in the assessment. And when we provided our assessment, I was the coordinating lead author for the chapter on so-called attribution that looked into this. We of course checked out this null hypothesis that we could explain the observed changes purely by these types of internally generated variability, such as one term that has been used is this stadium wave type of effect, but it basically relates to natural internal variability. And we have found that the greenhouse effect dominates in terms of the last 60 years. And what you've got to remember there is the timescales are important here, and also what we call the fingerprint. So for the timescales, these modes of decadal variability very importantly vary the temperatures from decade to decade. That's a very important part of our climate system that we're seeking to better predict. But they do not provide the very long-term warming that we're seeing as a result of greenhouse gases. That's the first point. And the second point is that warming due to greenhouse gases produces a distinctive spatial pattern. More warming over land than ocean, higher warming at higher latitudes, that's different from these types of internal variability, and that allows us to distinguish between them. So it's fully factored into the assessment, where we conclude that the dominant the dominant cause of the warming since the mid-20th century is anthropogenic, not these natural factors.
Right. So if what I gather from what you're saying is we are creating the problem, but there are historical evidence there to show that it has happened in the past, but it's worse now than it was in times gone by. Is that fair?
Well, there's natural variations that have always happened and will continue to happen in the future, so we won't get a simple linear every year warmer than the previous year.
People that disagree with you will say that this is all natural and everything goes in cycles.
I think it's not all natural and it's not all anthropogenic. It's a mixture. Yeah. What we've got on all time scales is a mixture, and this makes it really difficult to understand and a very interesting scientific problem. But on the day-to-day basis, it's dominated by natural variability. And I was not part of this last IPCC. I've only been part of one IPCC report, actually. And if I had a criticism of IPCC, I'd say in the past there tended to be rather too much thinking that everything was being explained on the decadal, multi-decadal timescale from the greenhouse gases or the aerosols or the volcanoes. And I think there was perhaps an underestimate of the natural variability. And this recent period has been an example of this last decade or so where it's been very apparent of the natural variability. Probably in the 1990s, the natural variability was encouraging the warming. So it's disentangling these two, but with the very strong theoretical basis and the observed warming over a 100-year period, giving some agreement, then we're really seeing what we think is the fingerprint of our anthropogenic warming on that century timescale. But when you get down to the decadal timescale, then we see a lot of the natural variability tending to dominate.
I just wanted to chip in that disagreement on the role of natural variability over the past century is precisely reflected in the range of uncertainty and predictions for the future. If you have a look at your little Excel spreadsheet climate model, you'll find that if you go to the lower end of the response, you get a rather smooth curve over the past century because there's very little aerosols in that scenario, and you get the low end projections. If you go to the highly responsive model with higher aerosol volume, you get something which goes up and down more as the observations did, and gives you a high warming in the future. But then you look at both of them, you realize both of them are broadly consistent with the observations. There's just not enough in the observations to distinguish, say this one's right and that one's wrong. So we can't look at the observations and say, because the observations have gone up and down in this way, it must be natural variability, when there's an alternative explanation, which is that it's driven by the combination of greenhouse gases and aerosols. So we account for all of those possibilities in coming up with the ranges of uncertainty.
I'm afraid, too, it may be more complicated than that, because one of the really interesting and important climate changes could be a change in the natural variability. You get an interaction. So suppose the El Nino, for instance, had a different flavour to it in either the frequency or the intensity or the nature. And so one can't necessarily separate natural variability from climate change.
Okay.
Peter.
Could we move on to models? I understand that the full technical report scales down the projections for near-term global warming by 40% below that which the CMIP 5 global climate models gave. Is that correct? And why is it not mentioned in the summary for policymakers?
The revised range is mentioned in the summary for policymakers.
And not the fact that it's been revised.
So the range, in terms of the near term, there is a scaling of approximately 10%, which is estimates in terms of the comparison between the observed trends and the model trends. There is also, you also have to take account of the effectively the way the starting point for your near-term projections, and that's the two pieces of information that go into those projections in the summary for policymakers. And again, all of that science is fully described in the traceable account that underpins that report.
It's all in the technical report, which is extremely good. I just wondered why it wasn't in the summary for policymakers. The figures from the models is a range between 0.48 and 1.15 degrees, and the figure in the technical report is revised down to 0.3 to 0.7 degrees. That's a 40% reduction, or 10%.
I think I was party to one of the conversations this, although I wasn't in Stockholm, and the firmly held view was the 1.15 degree number was not a helpful number to put into the summary for policymakers for rather obvious reasons. It was not the view of the IPCC authors that we were expecting to see over a degree of warming between now and 2035, and therefore it would have been, in the conversation about this, which I was party to, that carried a lot of weight, that it would have been misleading to have put that number, to have elevated that number too high in the process. The aim of the summary for policymakers was to summarise what we thought was most important, rather than the details.
You gave us a range that was based on expert opinion, not the models, but you didn't tell us that you'd lost faith in the models sufficiently to scale down as a result of expert opinion.
No, the short-term range is based on a combination of, like all of the ranges in the report, is based on a combination of models, of multiple different types of modelling experiments. There are also initialized experiments which go into the IPCC report where the models have been reconciled with recent observations, and one of the lines of evidence, these are new in the current report, and one of the lines of evidence supporting that lower range was obviously that the models which had been reconciled with recent observations were giving lower projections than the models which were just running free, because the models which were running free were already too warm by today because they didn't reflect the natural fluctuations which had happened over the past decade. Another point was a study which Peter Stott led, where you can use observations to try and constrain near-term future warming, and that fed into that assessment. So all of these assessments are based, you say that they're based on expert judgment, but they're based on a range of lines of evidence, and it's the expert judgment that's used to draw those different lines of evidence together.
That's right. It's also worth pointing out that the so-called transient climate response, the range of the CMIP5 model range, is consistent with estimates where you also bring in the observations and your understanding and your models together. In fact, this is what we're doing here. We're bringing models and observations and understanding together to give an overall assessment. But there's a consistency of all of that evidence which underpins that overall assessment on transient climate response, which, as I say, is overlapped strongly with the basic CMIP5 model range.
Well, it doesn't, of course. 0.3 is outside the range given by the CMIP5 models, which the bottom of which range is 0.48.
No, the point...
I think we can go on too long about this, but the point I'm trying to make is, the points you make, and particularly the points in the technical report, are all good science. But what you entrust us, the policymakers, to know in the summary for policymakers is sort of politicised. You think, we won't tell them that we've scaled down below the range given by the models. If that were done in the economy, today the Chancellor's going to give the latest figures for GDP. If it were to emerge that the figures he was given were not those given by the Treasury model, but his expert judgment, and he hadn't told us that, there would be trouble in Parliament.
I mean, I should have seen the process whereby the Chancellor comes up with his numbers, but I'm sure there's an enormous amount of expert judgment in running that Treasury model, and the key point is there's an enormous amount of judgment in running climate models. There's nothing sacrosanct about ranges that come out of the CMIP5 ensemble. We rely on a whole range of lines of evidence, including observations and these models, to provide these projections, and those are the projections which are elevated to the summary for policymakers. It's also worth saying, just because a model, you say that, just to pick up on one of your things, you no longer rely on the models. There are certain things I would never rely on these models for. There are other things that I would. And the point, that's where the expert judgment comes in. You have to look at a model and ask yourself, is it appropriate to the question that you're asking with it? And if you wanted me to use one of these models to predict whether there's a white Christmas in 2030, it wouldn't work. But that doesn't mean that the model is useless from giving us the big picture estimates of what warming we should expect over the coming century. So there's no mechanical process for taking a set of model results and turning a handle and getting a set of answers out. And I suspect there isn't really a mechanical process like that in the economy either, actually.
Well, you're certainly right there. But I understand they revert to using the model estimates after 2035 or wherever it is. So there's no sort of fudging in judgment. The models are assumed to be right in the longer-term future, but wrong in the near-term future. No,
that's an important... the models are not assumed to be right. What happens is, in the longer term, the lines of evidence coincide sufficiently well that we are able to say there's no evidence for the models being either an over or underestimate, and the model range, the 5 to 95% model range, so most of the models, are assigned only as a likely outcome. So even though you say the models are assumed to be right, but that's actually incorrect. I mean, explicitly in the summary for policymakers, we say there's a 1 in 3 chance of the real world lying outside that model range. Whereas if we just took the model range at face value, we'd say that was only a 1 in 10 chance. So in the longer term as well, we aren't just relying on the model ensemble, we're using it as one of the lines of evidence which are fed into the assessment.
That's right, and that was the point also I was trying to make earlier, that that overall assessment of transient climate response between 1 to 2.5 degrees Celsius, bringing in our information from the recent observations as well, is very consistent with the overall 5 to 95% range of the CMIP5 models, which is from 1.2 to 2.4. So you can see how there's a consistency of evidence there.
A recent paper by Swanson et al., published last year, Emerging Selection Bias in Large-Scale Climate Change Simulations, says the remarkable thing is, between the previous generation of models and the one currently used, there's been a greater convergence between the models. The models now agree with each other much more, but they agree with reality less. The previous range actually did sort of include reality in the range of projections that the models did. He suggests that that's partly because there's a natural tendency for model builders to try and agree with each other, and partly that they're all trying to simulate what's happening in the Arctic. Would you agree that A, the basic phenomenon is true, B, that it's worrying, and C, that the reasons given are valid?
So, I mean, actually, if you look at, I mean, we looked at this in research that we did at the Metals Hadley Centre, but if you compare the CMIP5 range with the CMIP3 range, you'll see there's a larger spread reflecting, the fact that we are taking more fully account now of things like the aerosol forcing uncertainty that we discussed earlier. So there is, in fact, a larger spread in those model runs, and that is part of the assessment. Now, if you assess those models against the longer term climate changes, we've always expected that there would be variability. It comes back to the point about variability. That's been talked about in IPCC reports going right back to the first report about the important role of variability from year to year and decade to decade. So we've always expected to have periods of faster warming, which we saw leading up to 1998, and periods of slightly slower warming in terms of the surface temperature response. But what we've got to remember there is that that's an imperfect measure. That surface temperature index is an imperfect measure of what we're really talking about here, which is the energy imbalance as a result of the enhanced greenhouse effect. And what we're seeing there is we're seeing, about 93% of the additional heat is going into warming up the ocean. And we're seeing, if you look at measures of the overall energy of the climate system, that's continued to increase over the last 15 years. And if you do the assessment of the models against a whole raft of climate indicators over those longer-term timescales that you need to do to assess their fitness for purpose for the longer-term changes, and we did this in this study that Myles referred to earlier, and a number of studies have done this, we see that the models do a good job of representing the larger scale, the larger time scale changes. We see the potential that the very, very most fastest warming models may be slightly less consistent, and we have this potential to scale by about 10% we've already discussed. So, but on the broad scales, the models are validating well against the observations.
And just this point about, if you don't mind, just this point about the models agreeing with reality less. I mean, in order to make a statement like that, you have to choose some aspect of reality that you decide to compare your model against. Okay, so the surface temperature, which of course is problematic because it's contaminated with internal variability, and we may just be in a particular, it may just be that what we've seen over the past decade is a random fluctuation, which you should, which you would take many, many more models than we've got in the CMIP ensemble to reproduce. But, there's that study which Professor Hoskins mentioned earlier, where they're specifically looking at observations of reality which are particularly relevant to the feedbacks which determine climate sensitivity. This study published recently showed that the models which agreed with reality best were the ones with the very high responses. So, and that, of course, is the observation of the world that's particularly relevant to that process. So if you're testing models, you have to test them against there's obviously an element of judgment in that and deciding what's most relevant to understanding the model performance.
Those combined were quite long answers, and I'll read them with interest to see whether they actually provide me with answers. My question, the point you just made, was that the models which were best for clouds were worse for temperature, which is interesting. But aerosols, another area where there's been a change in the evidence between AR4 and AR5. AR5 says, and a fleeting mention of, even gets into the summary for policymakers, that the impact of aerosols has been scaled down significantly. Has that evaluation of aerosols been applied retrospectively to models to see whether they now fit the data as well as they previously were thought to when we were using the wrong figures for aerosols? Or has that not been done? And won't it mean, if the aerosols have been less powerful than we thought, the climate sensitivity must have been less powerful than we thought?
Well, I'll kick off there. I mean, they have been taken into account in the attribution chapter that I was the coordinating lead author of. We do not take the models at face value. We combine the observations with the models to understand.
So they've been
in our
rerun with the
assessment.
new aerosol figures. That's what I'm
Excuse
asking.
me?
They've been rerun with the new aerosol figures. That's what I'm asking.
We have a whole raft of models
Just
that
yes
have been
or no?
run with. We haven't rerun the models. We've taken the models which have a whole range of forcings. But then.
So that exchange might be a little bit misleading. There's a range of aerosol forcings in the models, and some of them match the new estimates. So when you say
some of them were right, even when the figures were wrong.
no,
And
I mean there's a
others-
range of uncertainty and there's a range of what goes into the models. I mean I don't think there's an obvious
But when you've got
inconsistency
new
there.
data,
Sorry,
don't
Peter,
you
jump in.
feed it into the models, is what I'm asking.
Yes.
Of course we do.
Yes, we do. We do.
But you said you
feed new
haven't.
data into the models. And so we have a new generation of
Could
models
you
in the
write to
sim
us
side.
afterwards and tell us which is true, whether you have used these new data retrospectively and seen whether the models now fit as well, or whether you haven't? Because it's not clear from your answers.
Okay, I can answer specifically on that. With the simple models we can run quickly on a PC, such as the one I provided you all with, yes. With the very complicated models that take several years to run, the answer is rather obviously no, because these estimates were only available last year. So, obviously it's not possible, but then you can imagine CMIP 6 will use these new estimates. And that just reflects the different timescales of different types of modelling assessment. However, it is worth stressing, when you put these new estimates into the simple models, okay, you get the range of uncertainty that is consistent with the ranges which are in the IPCC fifth assessment. So the point is, yes, I mean...
You're trying to get a different range of uncertainty.
Which
it
is...
may overlap with the previous range of uncertainty, but it will be different.
If you the range of uncertainty in the AR5 projections accounts for the possibility that the aerosol forcing might be very small. In fact, if you can try it out yourself. You don't need to take my word for it on that. If you put in an essentially zero climate aerosol forcing, that's when you get the best fit with the lowest end of the range. But that doesn't mean that's correct. The aerosol forcing might be much higher than zero. So that full range is accounted for.
Robert.
I should remind the committee my entries in the register of members' interests, in particular to do with the oil and gas industry and shareholding in Shell. Been quite a talk already, though, of the language of uncertainty that goes with these reports, and some concerns expressed that the IPCC causes confusion for policymakers and the media in its use of uncertainty. Is there any need to clarify the language of uncertainty?
The language of the IPCC, they do try and quantify. I mean, I say they, not we, because it's not me. They do try and quantify the uncertainty, and sometimes I wonder about that quantification, but it's perhaps useful to know what the language means. But I think it is helpful to give confidence ranges and in the way they're doing. That then reflects the expert judgment of all the bits of evidence they have available to them at the time they make this. And the confidence in certain aspects then may change over the years, and that reflects how the level of understanding and the observational evidence has changed.
I think I should stress that we had a guidance note, so we had very clear guidance on how to use this uncertainty language, which provided us with calibrated statements, and that allowed us to provide a well-calibrated assessment across the report. And that guidance note basically allows us to quantify when we have high agreement across multiple lines of evidence, when we have robust evidence, and where we have quantitative estimates, probabilistic estimates, we can then provide these likelihood assessments. So we had very clear guidance, which is produced by the IPCC, which is authors we could work to, and then of course we can then, as a communication tool, we can then, and that's provided in the summary for policymakers, there is information about what those terms, those confidence terms, and those likelihood terms mean.
I'm not quite sure. I mean, when the IPCC says something's very likely, I mean, you know, it's explicit. It's explained what that statement means. It's an assessment based on the lines of evidence available of the probability of something occurring. That's what the words mean. I mean, I accept that there's many different views, and if you put two statisticians in a room, they'll probably start arguing with each other about exactly how to do these things. But I think, you know, it represents a reasonable effort at communication. Is there anything specific you wanted to focus on?
The Inter-Academy Council recommended the implementation of a calibrated uncertainty language, but it sounds like it is calibrated.
Yes, and the Inter-Academy Council suggestions were very helpful, but it was actually reinforcing a direction that the IPCC was already going on.
That's right, it was reinforcing that direction, but this was a cross-working group document that was produced across the working groups of IPCC, so that we're using this common understanding and this common calibrated language, which was in response to the Inter-Academy Council, but, you know, as was said, following that direction the IPCC was going.
So which are the main areas where the certainty level is increased, and which are the main areas where it's decreased since the last report?
Well, I mean, one area to kick off, one area to talk about is in terms of the evidence for human influence, where we have more evidence from across the climate system, and so there is a conclusion that it is extremely likely. So in that calibrated uncertainty language we've just talked about, that means greater than 95% confidence that human influence has been the dominant cause of the observed warming since the mid-20th century. So I think that's one of the important areas, and I think we have also this new science around cumulative emissions and the link to warming, and we also have stronger confidence around extremes as well. We're seeing evidence for observational evidence for changes of temperature extremes, and we're also seeing evidence that we can link that to human influence on climate through increased greenhouse gas concentrations.
I mean, you asked specifically for a case where we were saying something that was explicitly less confident, so we were expressing lower confidence than was expressed in the previous report, that the climate sensitivity was greater than 2. Although actually we weren't much revising the range for the more policy relevant TCR, so in fact that change doesn't actually make much difference to the projections. If we stabilise, then there's that revision changes the range of outcomes. So, but that's, if these ranges are correctly specified at any given time, you should not expect that they will always get smaller. I mean, this isn't a ratchet. If we give an honest assessment of uncertainty, you should expect that to wobble as we proceed into the future. And I think this committee should appreciate that is what happens, because at any given time, these assessments represent the state of the evidence at that time.
Can I just add to that? I mean, I think one of the amazing things about the IPCC is how this equilibrium climate sensitivity range has stayed the same over the years. And that would seem like, haven't you been doing any science to try and refine this? But during that period, those started with an atmosphere-only model with a sort of fixed ocean underneath, and then gradually the system has become the whole depth of the ocean involved, by the vegetation on the land, the ice. The system has become so much more complex and interactive that's modelled, and uncertainty ranges could well increase as you do that. And the triumph has been that most of them have stayed about the same.
It may come up later, so because one of the submissions to you, the IPCC was criticised for not using a very specific branch of statistics, so-called objective Bayesian methods, in quantifying our uncertainties. The job of the IPCC is to be inclusive. I mean, so we have to assess, what the full range of literature, the different methods that different people use. And obviously, every author likes their own method. I was a bit of a fan of objective Bayesian methods a few years ago, but I mean, there are problems. It turns out that they have paradoxical consequences as well. So what the IPCC ends up doing is assessing the range of methods used in the literature and presenting results accordingly.
Is it possible in the time we've got to sort of summarise why there was an increased confidence in the human influence?
Yes, so we have more evidence across the climate system. We have evidence in terms of the ocean warming in particular. We have better observations now, and we understand not just the changes but the variability in ocean temperatures. I mean, of course, if you're going to measure temperatures below the surface of the ocean, you have to send buoys down to measure those temperatures and so on.
Isn't that more confirming the outcomes of warming?
Well, it's increasing our level of confidence. Sorry, excuse me. Yeah.
I'm just trying to pin down. That's a sort of symptom of the system warming, but how does it increase the confidence that the human activity was the cause?
Well, what we're seeking to do is to quantify the overall role of human activity.
Yeah.
I mean, as I said, our null hypothesis starting point is that we can explain it just by internal natural processes. And we can rule that out at very high confidence levels. But then it becomes a question, this so-called attribution question of how do we quantify the human role. And as we've already discussed, as a starting point, it could be that it's dominated by natural factors and that human factors is rather small. So this is where we have increased our confidence in saying that extremely likely more than half of the observed warming, therefore the dominant cause, is human influence. And to do that, you need to bring all the evidence to bear, including, importantly, the ocean temperatures. Previously in the AR5, there was a lot of variability, apparently, in the observational record, which we've now understood was an artifact of different biases in those measurements. So that's one example of where we've improved our confidence. But it's not just in terms of ocean temperatures, it's also in terms of other factors such as the retreating ice and snow. We've developed our understanding of the water cycle, we've developed our understanding of extremes. And when you look into our chapter 10, you'll see we've got a table at the back there with 33 rows where we've itemised all the evidence, both the evidence where we have multiple lines of evidence and also where we have remaining uncertainties. And we have a greater wealth of evidence now than we had, with better understanding, with more observations, and also with the improved models as well.
And just briefly on this, to come back to the earlier conversation, I recall one of the big arguments in AR4 was over whether human influence via aerosols could be masking the human influence due to greenhouse gases. So that was one of the big uncertainties. Now that uncertainty has now come down because we're more confident that the aerosol forcing is not at the really high end that was considered possible back in AR4, and that of course increases our confidence in the size of the total anthropogenic warming over the past 50 years, because our confidence about anthropogenic cooling
means it's less.
No, because aerosols cause cooling. So if you have less aerosols, then the total anthropogenic warming.
If there's been less cooling.
No, the total anthropogenic warming. If you're saying you're more confident that the anthropogenic cooling is less, then obviously the total anthropogenic warming your lower bound on your total anthropogenic warming goes up. No, we're more confident that humans are not cooling the climate, therefore we can have greater confidence that the overall effect, including all the warming factors, is towards warming. I mean, that's just one of the factors which play in.
Live in the real world. Know how much warming there's been. It's how much warming there's been. It's not how much warming there is in a model. There's been, let us say, 0.7 degrees warming. If that's not the result of 1 degree warming through CO2 and 0.3 degree cooling through aerosols, but if, for example, there were no cooling through aerosols, then the amount of warming through CO2 must have been 0.7.
Yes, but the statement refers to the total human-induced warming. And we're greater,
exactly.
We have greater confidence in what the total human-induced warming is than we were able to give in AR4. So that's an example of the increased confidence.
We're increased confident and a smaller amount.
Actually, No, I don't think that's a correct representation of the conclusions. But the key thing is that by ruling out something that might be compensating for the warming effect, by assigning a lower probability to something that might be compensating for the warming effect of CO2, you can increase your confidence that the overall human influence on climate is towards warming. I'm sorry if I haven't made myself clear on that. I've done my best.
I think what Mr. Woolley was saying was the net of... You're talking about the net effect of human activity.
Yes, and that's what the statement
and what Mr. Woolley is making the point that if there's less human input to cooling, then the human input to warming. Because after all,
yes. Okay. So this uncertainty in aerosols is reflected in our uncertainty in specifically the warming attributed to greenhouse gases, which of course is highly relevant to quantifying uncertainty in the future. And as I emphasised before, it's that uncertainty which contributes. It's a very substantial range, that uncertainty which contributes very substantially to the range of uncertainty in future projections. This balance between aerosol-induced cooling and greenhouse-induced warming. But this was specifically focusing on how much of the warming over the past 50 years is attributable to overall human influence, and that's a situation where our reduced estimates of aerosol actually helped increase your confidence in the total human influence.
Given this increased confidence and what you were saying, all of it at the start, that there was a slightly increased consensus about broad conclusions, one of the terms of reference to this inquiry is do the conclusions of the Fifth Assessment Report strengthen or weaken the economic case for action to prevent dangerous climate change? Do they strengthen or weaken that?
Given that we've had another 6 years or so of observations and of developing climate theory, modelling, etc., then I think it strengthens in that we have found nothing to go against the previous line that suggested the actions were necessary. Then there is still even as strong or stronger evidence that we are performing a very dangerous experiment with our planet.
One conclusion of AR5, which I think is very pertinent to this, is this accumulation of carbon in the climate system, the fact that the best determinant of long-term warming is the total amount of carbon we dump in the atmosphere rather than what we dump in any particular year. One consequence of this is that as long as emissions continue to increase exponentially, the long-term committed warming increases at the same rate. So since emissions have been going up at roughly 2% per year, over the past 5 years, the committed warming we get, if we, by simply continuing to dither, has gone up by a similar amount. That's just as a consequence of the accumulation of carbon in the system. So that's a good indication. If the actions we would have needed to have taken to meet a 2-degree target in 2010, if we postpone those actions to 2015, they'd only meet a 2.2-degree target. So that's how rapidly the target is receding away.
And just to be clear, that even if the rate of emissions was to stop increasing and to start decreasing, there would still be emissions, so the concentration of greenhouse gases in the atmosphere will continue to increase, even though emissions themselves are coming down.
Absolutely.
That's a tremendously important point. Until we stop, until we bring net carbon emissions into the atmosphere close to zero, we're going to see continued warming. And that does have, I think, quite profound implications for policy.
Can I just add to this? In the Climate Change Committee, we used the latest IPCC AR5 estimates of transient climate response as a basis for rerunning the calculations to see how our UK targets would fit into a global context. And the results, the range is really very similar to before, and the emphasis of that our target is well-based is still there.
Yes, absolutely.
Just finally, to what extent does the IPCC Working Group 1 Fifth Assessment Report represent a consensus within the scientific community?
There are thousands of scientists, and you'll get a range of views, but across the vast majority of that, then they would say, well, my view has been taken account of. Perhaps I might have written it slightly differently, but I can see it's been taken account of, and essentially it's in the range there. As I said before, I can be critical of certain parts of the IPCC reports, but the consensus view that comes through, which is very difficult in a complex area like this, where you have different scientists doing different things, the system itself is very complex. To actually get a consensus is not a natural thing for scientists. And it's sort of demanded by governments and by the UNFCCC process to get a view that they can take on board, trying to synthesize the science that's around, so that they can actually have it and then say, well, what must we do on the basis of that? So it's not a natural process for scientists to go through this. But given that, I think it is a remarkable job that's been done. It's not perfect, but it's remarkable.
And as I emphasised at the beginning, I think what's really interesting, particularly looking at the submissions to this inquiry, for example, is that we are now talking about a range projected by IPCC and people arguing about essentially whether we're at that end of the range or that end of the range. They're not arguing that we're down here. So the situation has changed from the 90s in that we're no longer arguing that the climate's not changing at all. The argument is over where in the IPCC range of uncertainty the correct answer lies, and that's why the IPCC presents a range of uncertainty.
I think the discussion now in the field is around the regional aspects, the details of the regional aspects, say for the UK in future, and that's where, of course, having national climate programmes, national climate capability comes in. So it's about those regional details, which is really where the focus of the scientific activity is in, because the main headline messages of warming and human influence and the implications for future emissions in the very large scale are robustly supported, by the great majority of the scientists.
Yes, can I come in on that? I mean, I think what we've seen from the models over the years and from the IPCC is really a projection of a climate where the circulation, the weather, if you like, stays the same, but the whole system is warmer, so it sort of, you get a bit more rain out of it, etc. But there is no confidence yet on how things like the El Nino, the circulation, the storm track that affects us, how that might change. And this is really the challenge now, to actually get that, as Peter's saying, to get more confidence in what is the interaction between the natural variability, the natural processes, the phenomena like storm tracks, and this changing climate. And that's a real challenge, but it's one that has to be there for adapting to a changing climate. And you could say it would be very influential if one knew, for instance, had confidence how something like the Indian monsoon was likely to change, because the confidence at the moment is really rather small on such things.
Thanks.
Yeah.
Thanks. The organisation of the IPCC, there's been a lot of criticisms we've read in the papers we've got and the documents we've got. There's been criticisms of it being overly political, of it being extremely burdensome, and there's obviously problems with the image of IPCC. And since the ER4, the Inter-Economy Council criticised the IPCC and recommended a number of improvements to the practices and the structure. Have these been effectively addressed?
Perhaps I'll start, but the others who are involved can then follow. I think nearly all, I think there were 26 recommendations and 20 of them have definitely been given a tick. Most of those were to do with actually how the IPCC assessment was done in terms of the scientists, the review process. And in fact, it's in putting those into place has made it even more burdensome than it was before. It's a case where the review is so intense and the process has just become more burdensome. So for the scientists involved, I can say this, it is now a huge commitment to get involved. But the process, so they have been followed in terms of the assessment. And in terms of the response to criticisms, I think they've been involved. There were some in terms of the sort of IPCC head office, if you like, that I don't think have been followed yet, but perhaps it wasn't opportune to do so at that stage. It was almost committed at that stage. So not everything's been followed, but I would expect by the next one, if there is, then it would be. But the question over whether the process has become so burdensome certainly has to be raised as well.
So to follow up, and then so it is hard work for sure, and we can both vouch for that. That some of these processes have been helpful. We have review editors, so their role has been in response to the Inter-Academy Council. The review editors have been ensuring that we do indeed adhere to the process. And we've already talked about the uncertainty language, and the clear guidance on that has been helpful to us as lead authors. I'd like to make one further point around politicisation. I mean, having been present at the final plenary meeting for the Working Group 1 summary for policymakers, it's very important to stress, and having experienced that, how clearly that is a scientific process, that the scientists have the final word, the final veto on the sentences that go in. There is clearly, as rightly, a very strong scrutiny on the statements that go into that, and a very clear process in terms of making sure the language is as clear for the policymakers as it can be. It is policy relevant but not policy prescriptive. But it is not a political process, it is a scientific process where we as scientists had the final word in agreeing to that final document. I think sometimes there's a bit of a misunderstanding about that process, but it is very clearly based around the science and around the extent to which our assessment really does reflect, our scientific understanding as provided in the underlying reports.
I mean, I should probably respond to this because I may have been one of the people you've been able to read in the press criticising the IPCC process. And I think in the big picture, the key thing is to recognise that the strength of the evidence of human influence on climate does not rest on the IPCC process and whether, you've got however many thousand authors involved. It rests on the evidence. And I think in some ways the IPCC process has become so elaborate that it almost distracts attention from the evidence itself, and I think that's actually potentially a bit of a problem. So I very much hope it will be significantly streamlined in the future.
What areas of the ISA report haven't been effectively addressed?
As I suggested in my previous answer, I think there were elements to do with the IPCC head office, the head of the IPCC and the organisation just under that, which doesn't really affect those involved in doing the report that much, but it is actually, the sort of infrastructure on top. So I don't think those were carried out at that time. I think the argument was that it was too close to the next review to actually make a major change in their structure at that level.
Professor Allen, it's right. We've seen criticism from yourself with regard to the IPCC. You recently criticised them for the practice of producing exhaustive assessments on a 6-year cycle because you didn't feel it best served the interests of the governments whom the IPCC is intended to inform. How might these practices of the IPCC be altered in order to more effectively inform governments on current issues in climate change and climate science?
Well, speaking, I should stress personally here.
I'm asking the question personally.
Yes, yeah. I strongly support the Netherlands proposal, which I believe has been put forward to the IPCC Bureau for an annual assessment, which is not one of these, multi-thousand-page documents, but something much more streamlined, simply giving the Conference of the Parties an update on the science every year. If we were to do that, and then we have special assessments when the science actually changes and when there's some call for it, special reports. I think that structure, would work far better and would much better reflect the actual progress of science, which doesn't work on a sort of 6-year cycle, and it actually can have quite a one of the worrying aspects of the IPCC is how climate modelling activities, have to be kind of shoehorned into the requirements to do the runs for the next IPCC assessment, and that I think is unhealthy. So I think an annual assessment supported by extensive special reports would be a much better process. And this is the Netherlands proposal. I commend you to read that proposal. It's on the KNMI website. In my personal view, I think they're spot on. They're very sensible people, the Dutch.
Professor Hoskins, the Graham Institute, the LSE, have defended the IPCC and argued that some of those sceptical of its work have been guilty of misleading the public and indeed policymakers. Would you like to elaborate on that?
Sorry, what did I say?
The Grantham Institute, the LSE, is defended...
So I'm at the Grantham Institute at Imperial. So I'm not responsible for what LSE say.
I'm not saying you're responsible, but I'm just saying that it has defended the IPCC and argued that some of those sceptical of its work have been guilty of misleading policy makers and the public. I'm just wondering whether indeed you could elaborate on that.
Okay. I think the science is full of probing and discussion, and sometimes that gets into the media, and that's fine, and and each person will try and say that their view should be carried forward to politicians. I think one of the interesting stages we've reached now, in my discussion with some of those, I'm a sceptic, but with some of those who in the common parlance would be called sceptics, there's general agreement on the science now. It's a question of what actions should be taken on account of that. So I hope we've reached the place that we can say, well, there is a range, and some people might put their number on the bottom of that range. Well, okay, it's possible they're right, but we do have a range, and that we can agree on that, and then say, well, what are the sensible, what is the likely outcome of these projections, and what policies then should follow from that. So the science really, as was said earlier, the IPCC gives a range. If we can accept that and move forward, rather than probing particular things and waving one's own banner on that, let's say it is just about agreed. We don't know all the details, and let's move on to the next stage of saying what should we do about it.
Just to put it, I mean, if we're at the low end of the IPCC's range, there's a little note I wrote with Thomas Stocker recently, which made the point that if we're at the low end of the IPCC's range, we have to reduce emissions by 1.4% per year from now on. If we're at the high end, we have to reduce emissions by 2 point something percent. I mean, in terms of policies, in both cases, we have to reduce emissions by a challenging amount from now on. The remaining uncertainty doesn't necessarily have that much impact on many policy decisions we have to make. I mean, it's not to say we shouldn't make efforts to resolve it, but I think we should be thinking about designing policies to accommodate the remaining uncertainties rather than necessarily waiting until these uncertainties go away.
And finally, does the IPCC lack credibility? And if it does, how can that be improved? Be interested to get...
in the science world, the IPCC certainly doesn't lack credibility. And the IPCC doesn't exist except for the scientists who are involved in the report, as far as the scientists are concerned. And those scientists, whether it depends how you number it, but some 800 involved in writing that report. And having not been involved in this time, it was incredibly interesting to see what was going to come out, and incredibly interesting to read it. And I think in general it is viewed as a very positive thing, except for the burdensome nature of it and whether it is the right thing to do, whatever. But the assessment of one's science provides a sort of 6-yearly thing at the moment, which is just amazing for the young scientists to say, well, this is the state of the art, what can I do? So it's providing a superb assessment of where we are. And that's generally the thing in the scientific world. Of course, in the wider world, then maybe there'll be people with certain lines who wish to try and not give it this credibility.
I mean, I should say that I'm very, very proud to have been involved in the IPCC and as lead author in the 4th and 5th assessment report, under the leadership of the co-chairs of the Working Group 1, Susan Solomon, Chindahe, Thomas Stocker, who impressed on us the importance of robustness, comprehensive assessment, traceable evidence. And I think it's a remarkable achievement. It's this meta-analysis of the science. I think the IPCC has been a remarkable achievement to collect that evidence together and provide that assessment for the world. So I'm very proud to have been associated with that.
Thanks, Chair, and apologies to you and our witnesses. Sorry.
Just quickly on that, the IPCC author meetings, certainly the discussions in IPCC author meetings are extremely heated. These are the meetings where I see the science tested most critically by other IPCC authors, trying to establish whether statements are robust. I mean, that process is tremendously useful for the science. My comments, which you quoted earlier, were specifically not intended to question the status of existing IPCC reports. I was simply suggesting how going forward the IPCC could be more useful for governments than the current 6-yearly cycle.
Yeah, apologies to you, Chair, and the witnesses for arriving late. I was just interested in what you said, Professor Allen, about an annual report and your faith in the sort of Dutch approach. And I was wondering what the other witnesses' response to that would be.
I can see some advantages in that. Let me give one thing about the present process, this 6-yearly thing. It's been said that the modelling centres then all have to run on this 6-year cycle, and that's not the natural thing for them, and I totally agree with that. But there is an advantage that one has a body of results from all those models that one can look at the same time and analyse in great detail. So this bank of this data exists now, and many thousands of scientists around the world are interrogating that data, and it is all there at once, and one would lose that. So there's advantages of, I think maybe we've got to try and get some mix where there is a faster, slimmer process that actually maybe takes particular aspects. But then there is also a time for a sort of total look at what the projections are giving from all the modelling centres.
Well, just, Dr. Stott, before you come in, do you think how do you think that would impact on policymakers, though? I mean, you get the press, a frenzy in the press. You get sort of politicians reacting to that, and maybe one year slightly different to the other.
I agree. That's the other aspect, is that, like it or not, the present one creates a certain crescendo of interest, and it will be viewed very widely, what has been said, and those more or not regular, but sort of every 6 months, 1 year, whatever, or whenever it seems necessary, would not create the same political interest.
I mean, I think there is a value in taking stock every few years of where we are with the overall looking across the climate system. I think it is important that the IPCC takes this opportunity to take stock and look forward at how it could potentially do things differently. I think there is, from discussions among colleagues, I'm detecting a consensus, and we've touched on this already, around how can we can avoid it becoming ever more burdensome on the scientific community, this process. So I think it's important that is taken account of. Personally, I think that it would be interesting to try to see if we can break down the slight siloisation between working groups. So to take one specific example there, Working Group 2 deals with the impacts of climate change, and I think there are clearly areas in which we could maybe think about how we could combine some of the physical climate science assessment with the impacts better and not necessarily have that separated out in the way it is. Like I say, I hope that the IPCC does take time for all its successes, I believe, to date. I think it's now a moment for the IPCC to take stock and see how to go forward and not necessarily do it in the same way as before. Thank you. Thank you, Chair.
Thank you. I'm surprised really that you've got such high opinions and confidence in the IPCC process, because there's been some pretty high-profile failures, haven't there? It took the chairman 2 years to recognise that information from a press cutting in India had got into the report, saying that there was going to be an immediate and dramatic decrease in the Himalayan glaciers. We've had the world's leading expert on mosquitoes and malaria excluded from the process, and really an inaccurate analysis of the relationship between temperature and mosquitoes and malaria put into the reports. We've had exaggerations of the decline of the Amazon rainforest. One could go on. Why are you so confident? And doesn't this indicate there's something pretty fundamentally wrong with the process?
I don't think you could go very long on your list, actually. I think in 3,000 pages to find one little paragraph that was certainly misleading, was not on good evidence. I think that's if a student of mine in 3,000 pages managed to have 2,999 pages that were totally right, and then one paragraph was wrong, I think it was pretty good. But the IAC was said the reaction to finding, and there's one thing to have an error creep in, there's another thing to not react properly when it's pointed out. And there's no doubt the IPCC at that time did not react properly, and that was an IAC comment, and that's one that's been taken on board.
Can I just come back, Professor? Human beings make mistakes, I accept that. But this wasn't an ordinary mistake of putting not in instead of leaving it out. This was putting information from a newspaper cutting into the report when it's supposed to be a review of peer-reviewed science.
With this, where I thought the focus today was on Working Group 1, which is the science, and this was not in that. But this was in Working Group 2, which from the nature of looking at the impacts, one is looking around all sorts of countries around the world and trying to glean what information you can. And in that process, not everything is in the peer-reviewed literature, and that does give a problem. So in Working Group 1, there is an absolute thing of keeping to peer-reviewed literature, and that is a science that we're focusing on here. When one is looking around and trying to get indications of maybe the different number of butterflies in a region, you can't necessarily get information that is always in the National Academy of Science proceedings, which is telling you about butterflies in Afghanistan. So one tries, I haven't been involved in that, but they clearly did try too far to get disparate information. And my main comment is actually their reaction to it when pointed out was too slow and tried to say, oh no, we're all right. And that's the part that was wrong.
And just to emphasise, the error was pointed out by Gord Kaiser, a Working Group 1 scientist on the cryosphere. So that's an evidence that the scientific community is its own best policeman in terms of spotting these things.
Right, thanks. If we can just go back to the compilation of reports, you said in answer to a previous question that scientists have the final say in drawing up the reports. We've got a submission from Christopher Walter here which points out that actually the involvement of governments and their representatives in the drawing up of the process makes it a political process, not a scientific process.
I mean, I can only comment on my experience, which was at the plenary meeting for the 4th assessment report and the 5th, and of course being involved in the review process. And the review process in the second round of review does involve a government round of review, and it is the Intergovernmental Panel on Climate Change, and it is a document that is accepted and adopted by the government. So what happens in that process, that review process, both written review and in the oral process of the plenary meeting, which was in Stockholm in the 5th assessment report, was a scrutiny of the scientific assessment and a close scrutiny of whether or not that summary document represents the underlying assessment document, which is, runs to 1 million words or so in terms of the Working Group 1 AR5 report. It is a scientific process. Arguments have to be made based on the science, not on the politics. And as I said, scientists have the final word on the statements that appear.
I wasn't involved in the final theory of this one, but I have been involved in previous ones. And the interesting, the reason I think we need that process is that if you send scientists away and tell them just to write a report entirely in isolation, it's quite difficult to predict how people will interpret what they say because, we end up just spouting jargon and nobody knows quite what we mean. So you need that dialogue to make sure that the conclusions of the scientists have actually been correctly understood.
But I think, can I just say, I recognise there is a tightrope here, because
Yeah.
the IPCC is for governments in the UNFCCC process. And clearly governments and UNFCCC are involved in the setup. And then the scientists that go forward to be looked at to whether they would be members of the IPCC tend to come through a process of being fed forward by the governments in different countries. So, but then then the thing proceeds and then governments come in at the end. So there is a tightrope that has to be walked there, but I was involved in just one IPCC process, and I certainly did not feel the weight of a government of any country telling me what I should say.
Absolutely, I think I would really emphasise that certainly at the at the chapter level, the scientists involved are contributing based on their expertise entirely, and that's all. There's no government interference at all at that point.
No, I mean, of course, there's scrutiny as to whether we've used the appropriate levels of likelihood and that comes in both directions, as you would expect. And we provide the evidence, and we that's part of the important part of the review process, to scrutinise whether that's the correct assessment based on the evidence.
In the written submissions to the committee, there's been quite a lot of concern that many of the authors are activists with Greenpeace or the World Wildlife Fund. How would you deal with that? Is there a process of declaring interests or activism? Do you see it as a problem, or do you not see it as a problem that there are so many, essentially political activists in a sphere who are authors in this area?
I don't see it as a problem at all. There is a conflict of interest statement that we sign, and there are examples given on there. For example, if we are part of some non-governmental organisation or something, there's a recommendation that we should resign. So we've signed a conflict of interest statement, or we signed it as part of this process. We are first and foremost scientists, good sceptical scientists scrutinising the science. And the discussions that we had were purely on the basis of the science. They're not on the basis of political considerations or activism or anything else. They're on the basis of the science.
Speaking personally, many of my more environmentalist colleagues feel that I'm close to a dyed-in-the-wool sceptic as regards current climate policy, and that doesn't make any difference to my ability to contribute to IPCC reports on the science.
How do you ensure that all the scientific views, sceptical or otherwise, are reflected in the report? I mean, you've said you've just repeated it actually, that you're painstaking in that. How do you actually go through the process?
Well, we draft the chapters, and it's the way the process works, of course, is its openness, in the sense that we draft the chapters, and then these are distributed for review, and we get anybody who wants to send review comments in can. I think that's an enormous benefit of the IPCC process. And then we obviously go through all those review comments and make sure that they've been adequately addressed. And that's a way in which we can elicit input. That's although I may have made some remarks earlier which sort of sound like I was very critical of the sort of bureaucratic nature of the IPCC process, it does have its benefits, because it means that we draw in comments and thoughts from directions where we might not have done so otherwise, and that's very healthy, and that's very, very helpful to the science.
Going back to some of the questions that John asked previously, one of the things that puzzles me about the greater confidence that the IPCC now have in their analysis and predictions is the hiatus in increasing temperature wasn't predicted, and yet you've got greater confidence as that particular prediction was wrong. Now, I'm a chemist, not a mathematician, so I'm treading somewhere where I fear to tread, but my understanding of Bayesian analysis is that when you've got high confidence of something and you miss your target, then you should have less confidence, not more confidence. Why have you got more confidence?
Well, I wasn't part of it, so I won't say we, but let me say that there was no attempt, in fact the models were not in the position to predict the hiatus, because that would have been an initial value problem where they would have needed the observations over the whole depth of the ocean, and as well as more of the whole climate system, to start the model off like a weather forecast, if you like. That information was not available, and so they were just running and would not expect to predict that behaviour. So there's no way that actually counters the models. It's the sort of variability one would hope in long runs of the models they would show, and I actually suspect that the models do not quite have enough of that sort of variability in general, which means that climate can change faster in one spell and less fast in another spell. So they're probably slightly too uniform in their behaviour. But so the hiatus, in no way the There was no attempt, in fact, there would have been no ability to predict that at that time. That was a decadal prediction problem for which the initial data was not available. But perhaps I can hand over to
Maybe it's just worth pointing out that back in the second assessment report, there was a statement when it was talking about warming rates to 2100, the actual annual to decadal changes would include considerable natural variability. And this is part of what we're seeing at the moment and part of what has been assessed. Of course, it's been relatively challenging to assess this because we're talking about very up-to-date information, and therefore there has not been, for the cut-off date that the IPCC had, which was the 15th of March last year, there was not a huge amount of literature, but that literature was assessed. And in fact, the assessment that was made in the fifth assessment report has sort of been borne out by further evidence we've had since. So in the assessment, it talks about particularly the contribution from internal variability, including a possible redistribution of heat within the ocean. And we've seen some literature since then. Actually, we also discussed this in a series of notes that the Met Office produced as well. But we've also seen subsequent literature which has talked about the potential role of the Pacific Decadal Oscillation, all within a context where we've seen multiple indicators of climate change, including estimates of the increasing energy of the climate system continuing to increase in the last 15 years. So we need more work to do to further delve into exactly the details of that Pacific Decadal Oscillation and what that's doing. But there's a clear implication behind that, which is that there is an expectation for warming rates to pick up in future as the mode of that variability switches into the other mode.
Can I say, in a meeting in Downing Street in the late 1980s, I said we could easily have a decade that would be cooler than the previous one, and that would not mean the whole global warming thing had gone away. It's not unexpected, given natural variability, to get a behaviour like this, but there was no attempt to predict it.
You're obviously much wiser than the scientists at the University of East Anglia who said that children wouldn't see snow after 2003. You remember that one?
I was asked by an old school colleague who had a wife who had a business of hats, scarves and gloves, should she stop? And I said no.
Good advice. Professor Allen, you gave the standard answer before about what science is. It has to be reproducible and testable, and you have to be able to check. I took some interest in what happened at the University of East Anglia on another committee of the House of Commons, and it's absolutely clear there that Professor Jones and his colleagues couldn't reproduce their work, and they weren't prepared to share the information and the data sets that they have. Do you think, two questions really, do you think that was typical of the way climate scientists work, and do you think it has damaged climate science generally?
I absolutely couldn't comment on the allegation you're making about Professor Jones and his colleagues.
It's not an allegation. It was part of.
But I wouldn't want to get into a discussion of that because I'm not party to that evidence and so forth. It's absolutely not the way science works. Of course not. And the IPCC process. One of the benefits of the IPCC process is that it does encourage sharing between groups. As Brian mentioned, it means that we get sort of many groups looking at results, looking at model output and so forth, and that's obviously beneficial. And in fact, that's one of the perhaps thanks to the IPCC. Certainly, when I talk to my colleagues in physics about the way other branches of physics operate and the way groups sort of keep their results to themselves because they're terrified of somebody scooping them. I think the climate science is actually remarkably collegiate in the way it approaches problems. Maybe not every aspect of climate science and so on, but certainly the sort of mainstream modelling, observation, comparison work which I've been involved in. I've always experienced a very open and collegial attitude to scrutinising other people's results and sharing of data. So I would firmly argue that certainly all the aspects of climate science that I've been involved in would not fit the characterisation you described.
Just one final question, if I may. It's a sort of deep question really. It's why are we here? I mean, if the Earth has been through large periods of, I don't just mean at this committee meeting, I mean, why have we survived if the Earth has had periods in its history when there's been great quantities of carbon dioxide in the atmosphere, which there must have been for it to get sequestered? How have we managed to survive? Is the atmosphere not more stable than the catastrophic predictions indicate?
There have been huge swings in the climate system on long timescales in the past, much larger than we're talking about. But we weren't around with our socio-economic activity at those times. And the changes we're talking about, there is every evidence that those would be extremely important for us trying to continue that socio-economic activity. So, yes, the Earth has been through those, but we weren't around with the sort of society we have.
And would it be fair to characterise it as, I mean, we're one of the most recently arrived species on the Earth, and that our phenomenal success in terms of proliferating in numbers and the extent to which we control our own environment and even in the very short term our own destiny, that success has been associated with a period of climate stability?
Absolutely, and I agree that that's the case, and it's interesting the number of extremes in this last period have exposed our vulnerability to our environment. Now, I won't get into the extent to which climate change is involved in those. However, they certainly exposed. Sorry?
Why raise them?
Well, because I think they show our vulnerability to our environment. So a changing environment, our society is very much hoping that the environment will keep within these bounds, and that's how we can continue our activity. And any move outside those bounds, whether in terms of extremes or the whole shift of the system, is something that would put huge stresses on society.
I mean, just responding to these two questions, I mean, is it... I find the predictions that humanity might be sort of somehow rendered extinct by climate change somewhat implausible, but the point is you don't need humanity to be rendered extinct by a process for that process to be undesirable or for it to make economic sense to curtail it.
Thank you very much for coming in. It's been very useful for us.
Thank you.
volunteered for good question. I haven't got you down. 8, that's 8 in that case. Okay, Albert, do you want to do 12? Yeah, sure. Would you like to take your seats? Can we move on to the second panel now? Thank you very much for coming in and for being so patient. We overran our time slightly, but that's because of the interest in the subject, I think, both from the committee and from the witnesses. Could I start by asking you which of the conclusions from AR5 give you the greatest cause for concern?
I'll start. I actually don't find very much of concern. What I find is a translation problem. In other words, I don't agree, for instance, with the arguments for attribution. But on the other hand, if man is responsible for 51% of the warming since the last 50, 60 years, that itself does not tell me that the sensitivity is high. And so it's completely consistent with there not being a problem. What I find strange is the popular translation of that statement into a statement that, catastrophe is around the corner. I don't think the IPCC itself says that. And so the question is, why are we depending on translations? And what is going on? From my own experience with the IPCC, and I was active in the third assessment as a lead author, the pressures were never political. They were, if there were any pressures, it was to restrain the participants from criticizing models. And if you asked, do scientists have an interest, I can only speak for the US on this, but in the US the reward for solving a problem is to have your funding ended. And so there is an intrinsic pressure to make sure a problem never disappears.
Perhaps I could say I see that my major, or a major concern with the IPCC AR5 report is that the observational evidence is pointing in one direction, and the model simulations are particularly for the future, are pointing in a somewhat different direction towards higher warming, substantially higher warming than the best observational evidence in AR5 implies. I think that's the given that all the policy relevant stuff is based on the projections from the models. I think that is of major concern.
So, are you saying that the models have somehow been twisted to not to reflect the evidence that's available so far?
I wouldn't say they've been twisted, but I don't think they reflect the current evidence. There was reference made in the first panel to the reduction in the aerosol cooling effect strength in AR5 compared with previous assessments due to better knowledge. And that is in some ways the most significant thing in AR5, because if aerosol cooling is lower, and as Mr. Lillis said, we know how much warming there's been, then it must follow that there's been less of that warming is attributable to carbon dioxide rather than being 1 degree or 1.3 degrees attributable to carbon dioxide offset by 0.6 aerosol forcing. It's a much lower figure attributable to carbon dioxide. And I think that that wasn't really recognised at the time when they started drafting AR5. It certainly wasn't taken into account in the models because they predate this reassessment of the evidence.
Okay. Professor Lindzen, I've seen a quotation from you saying that the small warming over the past 60 years is not a problem that's worth bothering about.
Well, what I'm saying is, as always, one is a little bit cautious in language. It's completely consistent with there being nothing to worry about.
How about some of the other conclusions, such as the rise in sea levels? Is that worth bothering about?
I think, I heard Brian say that he feels they're now confident about it. My colleague, Carl Wunsch, who's very much involved with TOPEX and the current measurements, feels you can't say anything about that at the moment because you have two different measurement systems and they haven't yet been fully reconciled. And so we're not sure what's going on with the sea level. We do know that, using the previous measurements, it's been increasing for thousands of years at a certain small rate. And indeed, there is some reason to suppose whether you had global warming or not, you might want to take that into account and how you develop land and so on. I don't see much evidence here that points to man doing something extraordinary.
Wasn't quite what I asked, was it? I mean, the conclusion of AR5 was that global sea level is expected to rise by more by 2100 than previously projected.
Yeah, I don't know where that comes from.
So you dispute the conclusion, in other words?
Sure.
Right. Are there any areas of climate science which you would now consider settled?
Yeah, I think there are quite a few areas that at least there is common agreement on. I agree with Myles and Brian. You never quite are completely certain, but I think we understand that man should have some effect. I think it's agreed that climate changes, and these have been the points of agreement that people point to when they say consensus, but none of this tells you that there's a problem.
Including the point about sea level rise.
Sea level rise, is not one of the points I said we agree on.
Right. Turning to the summary for policymakers, can that be relied on for policymakers? Can they use that?
How would you propose using it?
I'm sorry?
How would you propose using it?
Well, I think as a practical matter, it's unlikely that a lot of policymakers are going to wade through 2,000 pages of written material. So they will rely, I suspect, certainly my own instinct would rely on a summary. Now, is there any inherent danger in that?
Well, there is, of course, but the question I asked, in order to understand your question better, is what is it in the present summary that you could use for what policy? Because I don't understand that. I know it says summary for policymakers, but the part I don't understand is how the policymakers read this and translate it to policy.
Well, I think it was pretty clearly summed up by the previous panel that the fifth assessment report reinforces most of the conclusions of its predecessors, and that therefore a large number, I would say probably the majority of policymakers, will believe that that contains warnings which we should not ignore.
From a practical point of view, presumably we'll be looking at how much warming is projected to occur on various scenarios, which is set out clearly in the summary for policymakers, because that will drive what actions need to be taken to hit various targets. And from my point of view, I think that those projections, whilst they're within the range of possibilities, are probably centred about 60% higher than they would be if they were based on the observational evidence in AR5. And I think that should be something that policymakers are.
So you're also disputing the conclusions, in other words?
I'm disputing that particular conclusion. These are model projections. It's not the science, it's the models, which is different.
I was really looking at you, because I think you've expressed a view. I've got a quotation here saying, isn't a quotation, but you commented on the difficulty of condensing so much material into a relatively short conclusion.
That's right. So you start with thousands of research papers, and then a report, 14 chapters long, gets written from those thousands. So there's a lot of human judgment to decide what's relevant, what's important. And then we have 14 chapters condensed down to 31 pages. And so, again, there's a whole other level of human judgment. And human judgment, of course, is not science. The science was way back at the beginning before the papers got written, and then the chapters of the IPCC report got written, and then the summary got written. And if it were a scientific document, we would expect that the summary written by the scientists would be the last word, and that's what would be released to the media and the policymakers. But instead, it's almost like it's a summary by policymakers, because then there's a 4-day process where every single line in that summary written by the scientists is argued over. And it's behind closed doors. And, you know, It's very fine for the panel before us to say, oh, it's all above board and nothing, no, there's no political pressure. But we're supposed to just take their word for it. If there's no political pressure and everything's fine, why isn't that 4-day meeting open to the public? Why isn't it televised? Why are there not media present? If it's simply a discussion and a dialogue between policymakers and the scientists who've done the summary.
So you're suggesting that the scientists, having done all that detailed work, have a meeting with some policymakers and suddenly cave in and say, we're quite happy now to sign a summary which does not reflect the conclusions of our work. Is that what you're saying?
No, I'm not suggesting that. I'm suggesting that there is a potential for politics to influence the emphasis.
Well, I'm just going to drill down a bit further. This meeting, suddenly the scientists have got all their conclusions they've been working on for years.
That's right.
And they say, actually, we're not going to insist you reflect those in the summary. We're happy for you to dictate a completely different conclusion. Is that
well,
what you're saying?
No. They start with the summary written by the scientists, which is 31 pages, and they rewrite that summary. So I forget, it was 700 words less by the end of it, but 5 pages longer. So I think a number of graphs were put in. So it wasn't totally dictated, but every single line is put up on a projector and is discussed for 4 days by political people, not scientists.
I mean, I think it's fairly obvious that what the previous panel said was that you could trace everything in the summary to the text. That's probably true, although they allow the process to change the text in view of the summary, which is a little bit suspicious. But there is always selection. There would be a statement, should you say that? Should you not say that? That still allows you to trace it back to the text. What is clear is 31 pages leaves a lot out from 1,000 or 2,000 pages. And that too, sins of omission can be as great as those of commission.
And so have we got large numbers of scientists protesting that their conclusions have been somehow edited out?
No, but we don't have, we didn't see
why
a
not?
large number.
If what you're saying is true, why aren't they protesting? I mean, in my experience, many of the authors of these papers on which all this is based are not in the least afraid to express their views if someone else disagrees, and they'll say, come on a bit, you haven't reflected what we've said. Well, why? Is there some kind of giant conspiracy here that we haven't noticed?
Of course not. But the chairman of the IPCC has gone around publicly for years declaring that the entire report is based 100% on peer-reviewed literature. Well, in fact, that's not the case. About a third of the sources cited were not peer-reviewed literature, and thousands of people who worked on the IPCC report knew that. But none of them talked to the media, none of them protested that the chairman was misrepresenting the process.
You moved on to a different point. Are you abandoning your assertion that the summary is somehow not an accurate reflection of what the scientists think?
No, I'm sorry, I don't believe I made that. I made that assertion. What I said is that there is a potential for political interference, and because it's happening behind closed doors, there aren't a lot of checks and balances to assure us that the political interference hasn't happened.
So there's a sort of conspiracy of silence amongst the scientists not to say anything if their views were altered at some point.
Well, I think you understand. For instance, in the third assessment where I was involved, there's nothing in the summary about our section. It's taken for granted that the 30 pages are not going to include everything. I felt comfortable that the section I was participating in did not, and the guidelines we used for that were, we agreed we would say nothing overtly false. I mean, it's a process that involves intrinsic compromise. And to then, in retrospect, say, how did you let that happen? Well, you're dealing with volunteer efforts, you're dealing with an understanding that the summary is not going to deal with the bulk of the text. I don't know why you would expect there would be loud protests.
Well, I think if I was a scientist who'd worked hard on a particular aspect of this and found somehow that my conclusions were not reflected, if they were not, if some false picture was painted, I don't think I'd be inclined to stay quiet about that. I think I'd be pretty cross about it.
It's interesting, I mean, that you say that. I mean, for most of us, it was an extraordinary bother dealing with the IPCC. Remember, for about 4 pages that I was actually involved in, I had to circumnavigate the globe 2-3 times. And like most of my fellow participants, I never participated again. It was just too much of a drag on one's time and effort.
So you think it should be done on a more slipshod basis, less thorough?
I'm not supporting that statement, obviously, but I'm also saying, in practical terms, there's a limit to how much time one can devote to the IPCC.
It's certainly an original line of criticism of a scientific document to say we put too much work into it, try and make it accurate. Anyway, we'll move on. John.
It may not be untrue, though.
We did establish in the previous hearing, I think, and perhaps Mr. Lewis can confirm it, since it was his evidence that drew it to my attention, that though the technical report indicates that they've downgraded the assessment, or reduced the assessment of the projection of temperature in the near term below what is indicated by the models, that doesn't get in the summary for policymakers. Am I correct in that respect?
There's a very oblique cryptic reference to it in Note 3 to Table 2, I think. But no one who hadn't read the original report would have the slightest idea what it was about. Effectively, it doesn't say.
And likewise, it wasn't shown up in the summary for policymakers, was it, that they haven't rerun the models with the new aerosol foresees, even though they would quite substantially alter the whole picture?
Yes. No. I think maybe they assume that because they realise that they think everyone will.
Could it not be, I mean, you're being very kind, could it not be that there's a certain feeling that we mustn't rock the boat, we mustn't encourage complacency, we mustn't put too much weight on things which might suggest the problem is a bit less than previously thought?
I certainly think they had a major problem between the models and the observational evidence, and I think they probably didn't realise that to start with, and by the time they did realise that, it was too late, really, to do anything about it, because so much of the report is built around the model projections, model simulations, and they couldn't really write conclusions which said, basically, we think the models are wrong. So they...
Leave aside the models. I mean, are you saying that these scientists agreed to present a distorted picture of the evidence and the conclusions of their work?
I think the uncertainty ranges are sufficiently great that they can say that they are not inconsistent statistically.
So this was not a distorted picture?
Depends what you mean by distorted. I don't think there's necessarily anything that was actually untrue that they wrote, but it can be. But I think that they didn't bring out the fact that the centre of the model range and the centre of the best estimate based on the observational evidence is actually substantially different now. I think that was it was not helped by the fact that they did have conflicting evidence, and it was difficult for them probably within their guidelines to separate the good from the bad.
John.
Yeah. This select committee is about analysing things we're told, holding government to account, and trying to make sure that my constituents and their families will live well into the foreseeable future. And I said something at the beginning of my previous questions about how if you get 2 doctors or 2 politicians or 2 of anything, you'll always get 2 people who'll argue with each other. And I see I'm not wrong. I also have a problem because everybody talks about politicians. The one thing that neither you or your previous group have talked about the influence of business and who pays for Mr. Lewis's research, who pays for your university and how it's come, and who organises to pay for your book, as well as who pays for the gentleman who was speaking before you for their work. There's always an influence, and therefore you've got to pay the piper. That's probably a good phrase, and that worries me because that's what I'm seeing here. Because never once has there been anybody mentioning about what happens if you just have unabated coal-fired power stations? What happens if you just let cars go along as they used to be in the past with emissions that would damage everybody's health? And at the end of the day, there would have been no improvement in people's lifestyles. The fact that people are living better, we're obviously doing something right. So what my disappointment is that why there's a criticism here. And I think Professor Lindzen said about nobody can be 100% accurate, and he's absolutely right, nobody can, but you have to err on the side of caution, particularly when people's lives are in order. And Professor Lindzen, the IPC criticised your approach in calculating climate sensitivity, and they said it was based on problematic assumptions. So, giving you a chance to answer that, how accurate were the IPCC in their assessment of your work?
Yeah, I really don't know, because we ourselves were critical of the work. It was a technical issue. You have feedbacks involving infrared, feedbacks involving shortwave. The shortwave has a huge noise to signal ratio. The long wave is crucial to the models, and it has a pretty good signal to noise ratio. And so to declare that it's discredited in some sense, I think was inappropriate. I think it's been confirmed by 2 other groups since then. So, including...
Don't worry about that, it's just a starting work.
Including Trenberth, who is very much on the other side, also looked at the data and confirmed that the long wave feedback was missing.
Yeah, what I'm really saying is, you criticise them and they criticise you. Mm-hmm. That doesn't mean to say that both of you are wrong or both of you are right.
I agree.
So, I mean, it is there. The problem we have in this committee is we don't have the luxury of being able to look both ways. We have to make decisions in government that says we have to go down a certain road. So are we going down the right road in having our concerns about climate change?
Well, I think, you're asking a policy question, and I think most of my colleagues would want to avoid it, but there's a kind of obvious one. What you're hearing is, it's entirely possible there's no problem. You're also discussing...
That would suggest there's a question mark in the sense of but. There's a but there.
No, I think if you listen carefully, the range of uncertainty allows for the possibility that, for instance, if you look at economists like Nordhaus or Toll or so on, or Mendelssohn, warming up to 2 degrees, they estimate, would be a net benefit.
Yeah, well, I don't really trust economists, to be honest.
Well, that's all right, but I mean, it may be up to 5 degrees of net benefit.
But there's money involved, there's a problem. That's always been the case. Therefore, people will always err on the side of who's paying.
Yeah.
Well, what are you addressing with money?
I like the idea of science tells us something and we have to agree because science says that.
But science is an interest in its own right.
Yeah.
And if you're going to go down that path, then you have to take account of the fact that scientists have their own interests.
Yeah. The money is all on the IPCC scientists' establishment side. It's not on this side.
This is an area where there's a government
I've been to
monopoly.
America a few times in the United States, and I wouldn't have said that.
Well, for science, if you look at it, especially climate science, it is virtually a government monopoly.
So why then are all these national governments going down the road they're going then? I mean, if you're right, then we are paying out a lot of money on things we shouldn't be paying out on.
And that's what I worry about. And I worry that...
Yeah, but worry's not good enough. I need you to convince me that they're wrong and you're right.
About what?
About climate change and whether we should worry about spending billions of pounds
and
investing into it.
I think there would be no disagreement here that whatever the UK is deciding to do vis-a-vis climate will have no impact on your climate. I think you'll all agree it'll have a profound impact on your economy. So you are making a decision to take a problem which might not be a problem, take actions which you know will create problems, and feel in the net you've done the right thing. That's for you to decide.
Okay, I think that's somewhat negative, but okay. Mr. Lewis.
Can I say one thing on that? So why should we consider one rather than the other? I think at the time of the previous IPCC report, what they were saying was logical on the basis of the observational evidence, and therefore pointed to there being a substantial worry. I think the big thing that has really changed is they've now got much better estimates of things like aerosol forcing in particular, the cooling effect, due to having satellite-based studies and other studies of working out what its effect is. And if that is substantially lower, and it's come down by it's come down from 1.3 to 0.9 since AR4, it necessarily implies that the warming from greenhouse gases must be substantially less than previously thought.
Are you a bit of confusion on that?
Okay, well, let me go down this a wee bit before I let you back in, Mr. Lindzen, Professor. The IPCC re-evaluated studies due to your investigations. You said that they had used inappropriate statistical methodology. Therefore, they re-evaluated their studies according, based on your evidence. So they have looked at it. They've looked at what you've told them. So does the IPCC's reassessment of climate sensitivity factor in your statistical methodology, improving the reliability of their estimates?
Well, it's not their estimates. It's other scientists.
Well, let's just call it them as a group.
Fine. Most of the bulk of the studies are estimating climate sensitivity, and from a practical point of view, estimating transient climate response is a derivative of estimating climate sensitivity. Use this subjective Bayesian method. Not all of them. Mine uses an objective method. One or two of them use non-Bayesian methods. And the non-Bayesian methods and the objective Bayesian methods give very much the same answer. The subjective ones, basically, the answer you get depends on the subjective assumptions you've fed in. Some of those use what's called a uniform prior insensitivity, which definitely biases up the results, particularly the upper end of the uncertainty range, greatly. Some of them use what's called an expert prior, which basically means, in practice, they fed in the assumed probability distribution of climate sensitivity or whatever, or aerosol forcing from the time of AR4, which was higher, and that has dominated their results.
And they've reassessed it?
They haven't reassessed it. They've then melded it with observational evidence, but because the observational evidence isn't that strong, where they've used an expert prior, that has generally dominated their results. So the studies are not statistically sound, most of them. No. They've not reassessed them. There were one or two studies which gave it on more than one way, and they've put in both of those ways.
And yet most scientists would disagree with you?
I wouldn't say that. I don't think there is the statistical expertise
in
Bayesian. Yes, I can. In the Bayesian theory in climate science, that there ought to be. Well, I can give you an example. In AR4, there were two coordinating lead authors of Chapter 9, which was the one that dealt with estimating climate sensitivity and related matters. And one of those was, as well as being a climate scientist, is an adjunct professor of mathematics and statistics, Francis Xaviers. If you read, he's the co-author of probably the most standard textbook on statistical methods in climate science. He mentions Bayesian theory at one point and says some statisticians use Bayesian theory. We don't deal with it in this book. So he clearly doesn't touch it.
Okay, so he's open and honest about what he did.
Can we return to assessment report 5 if possible? We're not.
Yes, I mean the point. I know what you're saying. I know the point. The point has to be made though that each time they do an assessment, it will change.
Yes. Naturally,
because the science will always develop as the years go on, and things will be better and easier to assess. So I would expect when they get to their 6th assessment, it will be different from the 5th one. I don't think that has to be criticised for that. In a lot of ways, I think they should be complimented on it. They might even get to the same assumption as you have by the time they get to it. I doubt it, but they could.
Well, I think they've already got to it in our 5 of my son. It just the models don't reflect it.
Okay, but it's whose model and who agrees. You have to agree with me, though, that in most cases, people are concerned, and scientists in general are concerned about climate change. And the right to be concerned. So if we take that as the premise of where we're going, then we take the advice that gentlemen and ladies like you give us. And at the end of the day, politicians have to weigh up the pros and cons of what they're doing. And hopefully, as you say, we get it right. Never be 100% right, we hope to get it. So let me ask this last question. Is the IPCC's assessment of the role of natural variability in climate change adequate? And if it's not adequate, how far out are they?
Yeah, I think it is not adequate. And I don't think there's much argument about that. Even in the model into comparisons, we know that there are no models at present that really do an acceptable job on ENSO, Pacific Decadal Oscillation, Atlantic Multi-Decadal. And there have been indications, I mean, our record is only 100 some odd years long. There may be longer periods. We understand the intrinsic time scales for heat exchange with the ocean can extend to 1,000 years. And so the fact that the models don't do this, and the fact that there are people like Sonis and Swanson and Tung and Zhao and other respected papers that attribute significant parts, if not all, of recent climate change to internal variability, leaves that wide open. And the fact that the system can change on its own is really an important advance in understanding, I think, for the public at large, over the notion that climate is at its peak at the moment and any change has to be due to something specific. We know that climate is always changing.
I remember a movie, I can't remember which one it was, I think it was called The Core. And the scientist, who was a bit of a pain in the backside, made a statement that science is the best guess. Nobody knows exactly what it is, but it's the best guess. And we have to go in the best guess. So you need to help us.
Yeah, but you know, the question is, how do you decide on policy? In other words, it's kind of a point of amusement. Somebody says there's a problem, and the politician says we have to do something.
Well, there lies your problem. Your problem's the science, our problem's policy.
Yeah.
I don't get involved in the science, and perhaps maybe you shouldn't get involved in politics.
If I might make a comment,
yes,
I'm a journalist with no scientific background whatsoever. And I had left journalism for 7 years. I got laid off at the National Post with 130 other people. I decided to do something else with my life. And then I started doing some independent research on climate change and decided I should write a book because I realized that there was a wide diversity of scientific opinion about climate change, but that diversity was not being reflected in the news reports that I was reading. So I thought I was writing a book about 10 reasons to be calm, cool, and collected about climate change because there are diverse points of view. And instead, I ended up writing an expose of the IPCC, quite unexpectedly, because the more I did some basic fact-checking about what we were told about how the IPCC works as an organization, the more concerned I got. And I compare it to a criminal trial. If we find out that there was bias amongst the jurors, then we have to throw out the verdict and start again. And what I see is there are so many questions and biases and potential problems with the IPCC process that I don't think it's trustworthy. I don't think any reasonable person can look at the IPCC in depth and say, we can trust this decision. And it's unfortunate. I wish we could, because it would be much clearer what we should do.
The best will in the world, you're one person and there's a lot of other people who disagree with you.
Sure.
And you've had your chance to sell your book, so Chairman.
Yeah. Yep. Have climate models improved since the last assessment review?
It's not my impression that they have. I mean, what's happened, for instance, with one phenomenon that I work with a little with the modeling group in Paris, there's something called the quasi-biennial oscillation, which I played a role in explaining many years ago. The wind blows from east to west for 1 year and then back the other way for the next year and so on, with an average period of 26 months. It's very well observed. It's around 100 millibars, about 16 to 25 kilometers, 30 kilometers in the atmosphere. In any event, no model got this. And yet we knew the physics of it. So models have begun fudging the physics. Now they call it parameterization. There are things they can't resolve. They force the model to behave the way nature is observed to do. Is that in advance? I don't know. It says we know how it's supposed to work. We know the models don't do it. We can make the models do it. You can add complexity to a model, and that has happened a lot, but it hasn't helped them do major things with ocean processes that are still known to be important. It sounds, we like to think of progress as kind of linear. You spend more money, you make it bigger, you get it better. But there's been no discernible increase in skill that has been associated with the advances. There are claims that regional climate has improved, but actually there are still notable errors in describing today's regional climate with current models. And so that naturally gives one pause with predictions. You have the modeling to comparisons, and you can look at an array of 20-some-odd models, each of which is predicting different results for a given region. That isn't a prediction. So, no, I feel the progress so far has not been awfully good in identifying the specific problem. There is some feeling that the resolution is inadequate. You say you start out with the basic equations, but you need to have very fine resolution for the numerical methods in the model to replicate what the equations are saying. The Japanese are trying to get closer to very high resolution. So far, not a lot has come out of that. So, no, I don't feel it's a matter of steady progress. On the other hand, when you have a report every 6 years, you have to make a statement, we've made progress.
Do you think the models are reliable?
No, of course not. If they can't get today's distribution of regional climate right, why would they be reliable for the future?
Well, how can they be improved?
If we knew, it's like somebody, I remember a woman once said, if you have error bars, you know there's errors, why don't you do something about it?
With regard to the hiatus, despite the fact that the decade between 2000 and 2010 was the hottest on instrumental record, there's been no net increase in global mean surface temperature since 1998. How significant is the 15-year hiatus to the overall warming trend of the last 150 years?
Well, let's break it down, because I think the IPCC actually did something that seemed obscure but was actually reasonable. It spoke about attribution for the last 50, 60 years. It didn't speak about it for the last 150 years. And that is because if you do the calculation, this isn't very hard, you realize the impact of man's emissions don't really become very significant until the last 50, 60 years. And so before then, we are dealing with natural climate variability. And we have incidents like 1919 to 1940, where the warming was almost indistinguishable from what we had from 1979 to 98. I just don't personally think that there is much to be said. I mean, natural variability undoubtedly accounted for part of that. Man probably accounted for some of that. And if you ask that man accounted for all of it, it's still consistent with low sensitivity. If you now drag away the aerosols, if you now say much of it is due to natural internal variability, you're then forced to lower sensitivity. And each of these is pointing to less of a problem. I know my colleagues mentioned a paper that said high sensitivity models were in some sense more accurate. But that was for a particular boundary layer property that had very little to do with overall climate. They said it just made low-level clouds look a little better. I don't know. I mean, that seemed like a reach, so to speak.
Yeah. Just for the sake of accuracy, did you intend to say 1890 to 1940? Because actually there was 1990 to 1919. 1919, sorry.
Yes,
okay,
1919.
Just so our note takers.
Excuse me.
Just on the hiatus, yes, natural variability may well account for a lot of it. But if that's on a declining phase, then it seems likely that it was on a phase that was boosting the warming in the previous 2 decades. And if you take a long enough period, natural variability will tend to hopefully sort of cancel out in the longer
There are a couple of things in it. You know, it's been pointed out, 15 years is not as significant as 30 years. It's more significant than 5 years. The longer this goes on, the harder it will be to support a high sensitivity. It's not a matter of there's a cutoff at any given period. And, you know, there's not much more one can say, except it wasn't predicted.
There's a quite nice graph, figure 9.9 in AR5, which shows a 25-year period to 2012. So it's got the rapidly warming decade from the late 80s to the late 90s as well. And that shows that the observational data sets support, and this is the lower tropospheric temperature in the tropics, which the tropics are a key area for climate. It shows that the observations show a trend of about 0.1 degree per decade, and the models span the range right from 0.1 up to almost 0.5 degrees per decade, with a big clustering around about 0.3 to 0.4 degrees per decade. So there are much, much faster warming in the models over the last 25 years, which is getting to a more serious period. They often talk about 30 years for climate, compared with the observations. And we're talking about a multiple here, of 3 times as high warming. So I think this indicates that the models are not to be relied upon.
So just to be clear on this point, you don't think there's any connection between higher greenhouse gas concentrations in the atmosphere and changes in the climate?
How do you deduce that from?
I'm asking Mr. Joe, are you saying we now have I think it is beyond dispute we have a higher concentration of greenhouse gases in the atmosphere. You're saying that has no effect on the climate?
Theoretically, it's supposed to have some effect.
But you don't think it does?
No, on the contrary, I think it should have some effect,
right.
and probably
so I just want to be clear
does.
on what you're saying.
But that is not the same as saying that it is the major factor. It's not the same as saying there's a high sensitivity. It's not the same as saying there's catastrophe around the corner. In other words, you can't take a relatively trivial statement that it has some impact, which everyone agrees on, and all of a sudden reach the conclusion there's a problem that has to be dealt with.
Sorry, Ian, I interrupted.
Not a problem. Just finally, the IPCC said that the hiatus is a consequence of recent volcanic activity and the redistribution of heat within the oceans. Do you find that explanation valid?
The first one, no. The second one, and this is, again, a matter of language, it's a very opaque way of saying internal natural variability is the reason. In other words, to say the heat is hiding in the ocean is another way of saying that there is always heat exchange between the upper levels of the ocean and the deeper ocean, leaving the surface out of equilibrium and leading to the surface undergoing climate change. So instead of saying, well, yeah, it could have been natural variability, they said that. And that was, I think, designed to make it opaque and confusing and does indicate a certain bias.
There's sorry, can I briefly on that, the AR5 report shows quite a high ocean heat uptake over the last decade, more so than in previous decades or the last 15 years. There's actually only been reasonable measurements of that down to approaching the 2,000 metre level since about 2004, when the Argo network of buoys that dive down and come back up again reached 50% coverage down to that sort of depth. And the most recent paper published on that, Lyman and Johnson, shows that over the period 2004 to 2011, and they don't have up-to-date data because they have to go through a data validation correction system, was only about 0.3 of a watt per metre down to 1,800 metres, which is, I think, under half what the AR5 estimate had. So the evidence that it's sort of increased heat going into the ocean doesn't appear to have the observational support.
By definition, the predicted warming that the models suggested should have occurred over the last 15 years, 0.3 degrees or something, that hasn't occurred, could have been offset by natural variability. And the IPCC report makes that point. It's a perfectly logically valid point. Doesn't it also imply that the previous heating could have been partly contributed to roughly the same order of magnitude by natural variability in the other direction? And does the IPCC report make that point?
It certainly could have been affected in the opposite direction over the previous 20, 25 years since warming started in the late 70s. I don't think the IPCC report brings that out. In fact, I think it, if anything, suggests that that's not the case. But it seems to me very logical. It's known that there are fairly long-term, perhaps 60, 70-year quasi-periodic variations of the Atlantic multi-decadal oscillation and other things, which one would expect, therefore, that you'd have hit an up phase and now you maybe have passed the peak and be going down. So it's entirely logical that it would have boosted it before if it's cut it now.
I think the IPCC actually did reference the papers by Tung and Zhao and Sonis and Swanson.
They did, yes.
Swanson.
They did reference
and Sonis and Swanson were arguing that it's completely explicable by natural internal variability. Tung and Zhao argued that half the warming of the period of rapid warming was due to natural internal variability. But obviously this was not stressed.
But either way, it would lead to a lower estimate of the
Absolutely.
sensitivity. The previous panel was suggesting they actually seem to be playing down the importance of sensitivity. Is it possible not to be worried about sensitivity and yet to be worried about global warming?
I don't think so.
All right. I hope I'm not misrepresenting the previous panel.
I think Professor Allen's point was that for policy purposes, the transient climate response, which is over approximately a 70-year period during which you've got forcing concentrations rising, is more policy relevant, which is true enough. It's not a property of the climate system in the same way as climate sensitivity is, which is more directly related to the physics of the climate system. It's a mixture of the longer term equilibrium climate sensitivity and the heat uptake by the oceans and so on. So you can, effectively, if you're estimating one, you will automatically be able to estimate the other. And if climate sensitive, given any degree of ocean heat uptake efficiency, transient climate response will increase with climate sensitivity, but less so because the oceans have a greater effect at high climate sensitivity.
Could I clarify something? Sensitive climates take longer to reach equilibrium than insensitive climates. If you had a climate sensitivity of 1 degree for a doubling of CO2, the system equilibrates in a couple of years. If you have a sensitivity of 6 degrees for a doubling of CO2, it'll take centuries. And so by taking transient climate, you're saying, if I fix it to 70 years, the climate sensitivities that are high will not manifest themselves. And you won't see much difference between a model that has a very high sensitivity and one that has a medium sensitivity. 70 years, however, will allow you to distinguish between, let's say, a 2-degree sensitivity and a 1, because those are both rapid. And so one will be able to, I think, and already sort of pin it down to much lower sensitivities than the high ones, even with the transient results.
But again, Myles Allen, who has clearly been sort of adopting a generous and open approach to those who are not core members of the team, said that there's now a broad consensus of the range of values in which climate sensitivity falls, and that your estimate is sort of within the range of the members of the team. A, is that true? And B, is the range of your estimates within the range of the team?
And the range of masses would go beyond the IPCC 1.5 degree at the bottom end. Not hugely, because there's a very sharp cut-off there because of the way the mathematics and physics works. I think it's more important point is that the central estimates are quite different, and that from a policy point of view, it's important what you used as your central estimate, because even if you've got if you've got a wide range, the probability could be concentrated at one end, or it could be concentrated at the other end, or it could be spread right over it, and those have quite different implications. And in fact, if you run these economic models of it for impact purposes, it's the extreme high end that has a disproportionate weight, because that's what leads to high warming that starts to cause forecast big damages. So
is it the case that the decade 2000 to 2010 was the hottest on record?
It's entirely possible.
Well, I'm asking whether is it? I mean, there's people like NASA and so on have expressed a view about it. Is it?
Well, I mean, it's always been a funny way of expressing things.
What's a straightforward question? Is it yes or no?
The answer is, if it is an increasing until then and stopped.
I'm asking whether the decade
2000
but I'm saying
2008, you're posing
I'm just asking a straightforward practical question. Is it the case that the decade 2000 to 2010 was the hottest on record?
Of course it is.
Okay. Now it's interesting that you're using that as evidence that somehow global warming is stopped. That we've just gone through the hottest decade of all time, and this apparently
hottest record of the last 150 years.
That actually global warming is not taking place. Anyway, we'll pass on.
We haven't argued that.
Yeah, I mean, you're saying something that doesn't make sense.
Oh, so it is continuing. Either it is or it isn't.
I mean, how should I put it? On a certain smoothing level, you can say it's continuing. It hasn't done anything for 15 years.
Except we just had the hottest ever decade.
Well, if it had been increasing until then that decade will be the hottest.
If I'm just clocked driving my car at 90 miles an hour, faster than I've ever done before, I don't find that convincing evidence. I haven't broken the 70-mile speed limit. I just don't find that very convincing.
Yeah,
anyway,
but you're saying two contradictory statements.
No, I think you are, actually. You're saying, yes, we have just had the hottest decade on record, but actually, no, there's no global warming taking place anymore. That trend has stopped.
No, nobody has said that.
He can answer. The professor can answer the question.
Say that.
No, nobody said that.
Okay, so it's continuing.
No.
Well, either it's stopped or it's continuing.
Well,
one or the other.
then you better use the right terms for each. If you're saying you're taking a 16-year smoothing average, then it's continued. If you're saying that the last 16 years are looked at in their own right, they haven't been increasing. If you say that it was increasing until the last 16 years, so that we're now at the peak and now it's leveled off, that level is still going to be at the level of the highest temperature. It's perfectly clear what each of these statements makes, is saying, but when you confuse them to be saying different things, then I don't know where to pick up.
Well, I'm just simply saying, it seems to me that the evidence we've just had the hottest ever decade doesn't seem conclusive proof that global warming has come to an end. Doesn't seem to me to be that.
Nobody is saying
Good,
that.
I'm glad you're not. Robert.
And you're withdrawing the statement that they had, are you?
No, I'm not. I was just trying to get clarification. I was just trying to get clarification that I thought Professor Lindzen was trying to say global warming, that the upward trend has come to an end. I thought that's what he was saying.
He
didn't say
never
that.
said it's come to an end. We say for the last 16 years it hasn't increased.
I don't think you get much further than this. I'm happy to be judged by what's on the record. Robert.
Just returning to the language of the IPCC and its way of expressing uncertainty, are you happy with its use of language for uncertainty?
Well, for the uncertainty concerning the attribution, no, of course I'm not happy. I don't know how that was derived.
And the uncertainty in terms of the words connected with the ranges of percentages.
Yeah. You know, again, they have no relation to the mathematical definition of those words. So, you know, you're using statements that do have mathematical meaning, but you haven't put them into a mathematical context. I'm not sure how somebody is supposed to deal with it. I would assume, but it's purely an assumption, they were meant to explain to the policy people that they're very confident about something. But by using the mathematical term, nobody was able to confirm by any analysis what they're saying.
And you've also said that consensus is frequently hurled at those who question alarm.
Yeah. Oh, but that's pretty obvious in a sense. Let's say you're a person, you know, you haven't studied science, and you know the world around you has a strong scientific component, and you're uneasy about it. Consensus is terribly important, because then you don't have to understand it, you just have to say, I go with the consensus. But I found in my experience, people who do that get very upset if one says the consensus is wrong, because then they're back where they started from. They have to understand the science, and they don't appreciate that. But consensus, you know, I don't think the previous panel also felt comfortable with the notion of consensus. Yes, there's consensus of simple things, but those are pretty trivial. They're not policy relevant.
And do you think the IPCC report represents a consensus view?
Probably, depending on the definition of consensus, I would say with respect to certain things, I think it's probably a majority opinion. So for instance, I think a majority of the people working in climate science will go with the view that climate is serious. I don't think that would be surprising to anyone. There are very few fields that would say my field is not serious. Other than that, there is so much penalty to saying that this is not an important problem that I don't think very many people would go out on that limb either.
Yeah, and on the other side of the argument, the Grantham Institute and Imperial College has argued that striving for consensus, there's a risk of underestimating the potential consequences.
I don't see much evidence of that. I mean, I suppose logically it's possible that, for example, I know with the Laboratory for Dynamic Meteorology in Paris, when they were doing the cloud simulations for the model into comparison, there were telephone calls frequently when they were out of the range of other models. Couldn't you do something? It could happen sometimes that this would lead inadvertently to a conservative view, but I don't know of too many examples of that.
Thanks very much.
Graham. Just, I think a simple question, just to clarify things for when we come to write a report. Would you agree that there is no scientific way of separating natural variation from anthropogenic warming?
Certainly a lot of effort put into trying to. There is the issue of fingerprints and so on. That hasn't been terribly successful so far. So I say at the moment, there's no good way of distinguishing them other than natural variability will not correlate particularly well with increases in greenhouse gas. Right. And indeed, much of the variability you see in the record does not correlate.
But there is no way of saying it's 50%, 30%.
The way people attempt to do that is to get specific estimates. So, for instance, what Tungan Zhao did was look at the records for central England that go back to the 18th century and see to what extent they represent the global mean when you do have records elsewhere, and use that to estimate the amplitude of long period oscillations. And then from that estimate, they estimated that on the order of 50% of the change was due to natural variability, since it pre-existed the impact anthropogenic. It's not rigorous.
Can I just put on that? Apart from studies like that, specifically trying to work out what influence natural factors had, in general, the studies that are done of the climate sensitivity and other things will assume that none of the overall effect is natural. They'll assume it's all driven by anthropogenic factors, apart from volcanic activity, which is known, obviously, but and solar. But they wouldn't assume internal variability had an effect one way or the other. It would be entirely attributed to drivers.
Right. The fifth report has been criticised for underestimating the role of solar cycles and the role of cosmic rays in cloud formation. Do you think that's a fair criticism of the IPCC report?
Yes. I mean, you're dealing with something that is very uncertain. Mm-hmm. It's pretty clear that actual solar variability is very small. We now have satellite data that shows that it's a fraction of a watt per meter squared. On the other hand, there is now some experimental evidence, and there's been hypotheses for decades, that things like cosmic rays, which vary quite a lot, have an influence on the formation of cloud condensation nuclei, which can change the brightness of clouds and also the ability to form sometimes. And this can amplify the effect of solar variability by a large factor. That's an unknown at this moment. The IPCC not only didn't include it, but it may not have any way of including it at the moment.
Thank you. You've said that you think the IPCC should be disbanded.
Yes.
Are you still of that view, and can you explain to the committee why?
When I started examining the IPCC, I found profound shortcomings, and I wasn't the only one. When the IIC reported in 2010, it said that there were significant shortcomings in every major step of the IPCC process. You know, that's not a mild criticism. That suggests that there are serious reasons to be very careful about the conclusions of the IPCC process. And you know, there is some feeling that some of the recommendations made by the IIC report have been taken on board, but other ones have not. And there is, for example, you know, the IIC said that the review process that happens at the IPCC is not independent. And they said, we have no way of proposing how to make it independent, because if it was independent, the review editors would be chosen by someone else, someone exterior to the IPCC. They would report to someone exterior to the IPCC. So, you know, we still have that problem at the IPCC. The review process is not independent. It is not, as an excellent submission to this committee pointed out by Ruth Dixon, it is not peer review, as that term is normally understood. So there are a great number of concerns about the IPCC process, and I don't see a significant improvement at this point, and I'm not sure actually that it can be reformed. You know, it has a culture, it has been around for 25 years, it's very difficult to change a culture. I think it needs to be replaced with something different.
Well, I know you said you found it difficult to say how it would be reformed, but if it's not going to be abolished, can you make recommendations as to how it could be improved?
I think there should be a Team B. I think there should be a minority report. I think there is the consensus view, and then there are alternative perspectives. And I think that people who are involved with the IPCC should be free to write a report at the back and say, I agree with these conclusions, but I have concerns about these ones for these reasons. I think that would be very healthy. And again, you know, we're told that these are the best scientists in the world. Why is it that they are nominated by governments? Why aren't the science societies nominating the best scientists in the world? It's governments who are doing the choosing. And again,
that's why we invited you here.
Pardon me?
That's a bit asking. That's why we invited you here.
Well,
waste of time. Well, tell me.
Well, but you know, there is a consequence to that kind of structure.
Yeah, actually, you've gone further than the IPCC would go on this, but I think how should I put it? First of all, with climate science, you're not dealing with a huge field. I mean, as I've asked people very frequently at university, how many people do you remember who were studying climate? Were the brightest people you know studying meteorology or oceanography? And the answer usually is they knew no one. If they did, they were not the brightest people. And suddenly we have a world full of thousands of the world's leading people in this area. That just goes against common sense.
But does that not go down to the breakdown of the ozone layer years ago, when we had scientific proof from satellites who took pictures of something that nobody ever knew about and didn't know was happening? And that started the ball rolling on climate change, did it not? Was that not really...
Why are so many astronauts skeptics?
Well, look, everybody's a skeptic. I'm a skeptic in most things.
But what I'm getting at is, you know, when you're dealing with something like the IPCC, it's manpower intensive. You heard someone this morning, I think, Stott, mentioning that, 58% of the participants this time are new participants. I know from my group, when lots of them have decided never to participate again. And they're on both sides.
Is that a bad thing, that new people...
It's not a bad thing per se, except in a small field where you have to keep finding people when there aren't any. And this is where Donna was coming in and saying, you look at the credentials of some of these people and you realize the world doesn't have that many experts. It doesn't have that many leading climate scientists. And so we're inventing something where we would like it to be that way when it isn't.
Were you suggesting just now that the people who've gone into this field of work were academically or intellectually inferior to those who'd chosen other fields of work?
Oh, yeah. I don't think there's any question when we were in college that the brightest kids went to physics and math, then chemistry and other areas.
And out of interest, do you think that's still the case? Because obviously climate science is talking about
I think so. The only change that has occurred is in my career, most of our graduate students came from physics and math. They were the overflow. That has ceased. It's also the case today that many of the brightest students don't go into physics and math. They might go into business, law, and so on. So things change with time, but your statement, although it makes people a little queasy to say my field is not as strong as other fields, is obviously true.
Right. Just going back to the point about the government appointing the scientists, are you saying the government is deliberately appointing scientists who are not so good as the ones who would be otherwise available?
No, I'm saying that depending on who the government is, they're going to choose, their choices will be skewed. A government in which Al Gore is vice president is going to make different choices than a government in which Bill Cheney is vice president. That stands to reason.
Which would be best?
I don't know.
You have an opinion, I've just read all of it. Again today here, so you have an opinion.
Yeah, thanks. Just on Professor Lindzen's remark about not many climate experts around, I get hundreds that write to me and to claim to be these academics are experts in this field, so I find that statement a little bizarre.
Depends on what you mean by
absolutely. But I just wanted to come back to the remarks about the IPCC and, Donna, you've called for it to be disbanded because of the reasons that you've given. And I just wanted to pursue them a little bit further because Professor Allen has told us in his evidence that there was a painstaking effort to include sceptical views within the IPCC. So there's a difference of opinion there. Would you like to comment on that before I
Yes,
ask further questions?
if I understood correctly, I think he said that skeptics were involved at the review level, not in the writing of the report, but that skeptics were free to make comments. Well, it's wonderful that I can make comments, but are my comments incorporated? And I think there's a submission by Marcel Kroc where he lays out a number of examples where people made very serious criticisms, and those criticisms during the review process, those criticisms were ignored. They were not incorporated into the report. So that's the difficulty.
Well, us as politicians are not sensitive souls. Wherever committee we set up, there's going to be criticism.
Yes.
So I don't think we're going to have a perfect scenario where, everybody's chosen and their views are going to be unanimity in the results. So I think you've been a little bit sensitive and probably playing the journalist role a bit there because you're looking for a story rather than sort of accepting. And I hear what you said. The colour of the government may have some impact on the appointments to very important panels. I mean, that's going to be the case. But if you get different countries with perhaps different colours of politics, you perhaps get a decent mix. Not a perfect mix, but a decent mix. So you wanted to
Brian may wish to contradict this, but I think I'm correct on this. In 1988, the number of countries that had intensive efforts in climate research were very few. There was the UK, the US, occasionally Norway, the Soviet Union still existed at that time.
Mm-hmm.
There was a little bit in Germany. There was almost nothing in France at that time. When you start working with the UN and you have representations from 50 countries, 60 countries, more, you're obviously having representation from lots of countries that have no scientific effort at all in this area. So you're immediately changing the nature of the expertise.
Sure. But just coming back to the structures and the IPC and the criticism that we've heard from you, Donna, on this issue. You know, some would argue that this is the most scrutinised document in the history of science. You know, because the 55,000 comments that have come to it. So, I mean, what are the documents that has had this kind of scrutiny, and why do you think that's not a good thing?
Well, I think that's a misunderstanding, because one of the concerns raised by a number of people, and I'm pretty sure the IAC raised it as well, is that the reviewers, who are volunteers, can review whichever part of the report they choose. Mm-hmm. But there is no one keeping track to say that every single part of the document was reviewed.
You don't argue it's not been peer-reviewed and been scrutinised, do you?
Pardon me?
You don't argue it hasn't been heavily scrutinised.
Yes, I do, yes.
Yeah.
Because there may be parts of the report that receive no comments from anyone. And in fact, we can see that in the review editor's internal documents, where they say there's a whole section and almost no one commented about this.
Why do you think that?
Well, because people are allowed to choose what they're interested in to review. It's a very haphazard review process from a certain perspective.
I can say
agree
from
on
personal.
That. Those are the parts. They might have agreed on those other parts.
Yeah, but you don't know that. And from my personal
Neither do
experience...
you. That's the point of this discussion.
Well, I remember with the chapter I was involved in, you get a box full of reviews. I mean, it's huge, that's true. You have a review editor, it was in this case Suki Minabe, and you just run through all the reviews. And here you have the authors of the chapter saying to Suki, you know, I don't want to deal with this. Suki saying, oh, that's okay, throw it out. And you just run through it this way. That is not a normal review. It's not a normal review when the authors play a role in deciding whether to pay attention or not to the review. So it's a different process, let's say. May have its virtues, but it's not peer review.
Okay. Coming back to a point that was made by the other panel as well, and I'd like to ask about, you know, if the IPCC was to opt for smaller reports on a more frequent basis, do you think that would arrive at better scrutiny? Would it help the process? You know, it's just a very general comment. So, Lewis, you're...
Yes, I haven't read the Dutch proposal, so I'm speaking slightly off the top of my head, but I think there is an advantage to having a fairly comprehensive assessment of the state of the science put down at one time, because it enables to examine it as a whole and see what implications the various bits of it have for other parts and see whether they're consistent or not. And in this case, the models and the observations are not really consistent. I'm not sure you'd still get that if you just had an annual, much lighter report. I can quite understand Myles Allen's concerns about the time it takes. I think to expect these academic scientists to do this on top of their normal workload is really not the ideal by a long way. But I think it is useful.
Any other comments from Donna on that? Frequency would give better scrutiny, or to improve the system?
One of the suggestions is that, you know, there are these massive reports. So part 1 of AR5 has come out, and I think it's 2,000 pages. And part 2 is going to be even bigger. And then there's going to be part 3. And who does read that? And one of the suggestions is, why don't they just focus on a few topics about which there is serious controversy, but which there are important questions, and just jettison all the rest.
The problem with that, somebody would criticise you've left a huge important issue out.
Well, sure, but you know, make a short list of here are the 10 most most important topics, and all of the rest of that, like Working Group 2 and especially Working Group 3, there's a lot of effort going in, and is it really serving a purpose? So I think I think it's one of the people suggesting this has just said, yeah, take the few really crucial scientific questions that are still very much open, and change the process, but concentrate on those rather than these massive reports that no one ends up reading anyway.
How about for the massive reports having an index?
An index. Just put a simple index there and people can
so
find
you
their
can
own
look
way
something
through it.
up.
But won't people look for things that they've got a specific interest with and ignore something else though?
Yeah,
Isn't
but
that the
at
danger?
present they are not terribly useful because there's no way to find things.
Okay. Can I, one final point I have, again back to you, Donna, on the objectivity of the IPCC and the remarks that you've made are attributed to you with regards to documents linked to activist organisations. Do you think it's heavily weighted to the WWF and Greenpeace's and others of this world?
The problem is that there are those people involved in very senior roles. So I know this is about Working Group 1, but Working Group 2 is about to come out in a couple months. And there are 3 authors, lead authors, not coordinating lead authors, chapter leaders, who have very definite activist mindsets. Okay, one gentleman has worked for an activist organization for more than 20 years, and according to his official biography, is still advising them. He's not merely contributing, he is in charge of a chapter. We have another gentleman in charge of a chapter who spent much of his career writing for pay for the World Wildlife Fund and Greenpeace. That is going to affect his view. He's not objective. He has a very particular activist worldview, and he has been put in charge of a chapter of what is supposed to be an objective scientific report.
But can't a young activist, in whatever role, be sort of mature into have different views as they progress when they see the evidence?
Well, it's possible, but
Well, it's damn likely as well, isn't it?
Well, no, if we were holding a criminal...
Well, I don't hold exactly the same views that I did when I was 16, 17, 18 and an activist in some organisations.
If we were holding a criminal trial, we would not put
That's not
someone...
a criminal
we would
trial,
not put... Well, but it is. The question is CO2 responsible for causing dangerous climate change?
So do you think their views should be ignored then? Or these people should be sidelined just because they have strong views or an activist background?
Yes, they should, if it's an objective
I'm not defending
assessment.
them, I'm just making the comments.
Yes, if you're telling me this is an objective assessment, you cannot put people who are bringing all this activist baggage.
You've got to have a sifting process where everybody has independent views to come on this body. Is that what you're telling me?
Yes, I am.
Okay. And do you think that's a little naive? Has that ever been achieved anyway?
If the future of our children and grandchildren are at stake, I think we should make an effort.
When we do that emotive thing, these have strong beliefs in as well as the future of our children. You can't just dismiss somebody because they have been an activist in the past.
Nobody is dismissing.
Well, that's the way I've read it, sorry, that's the way I think it's been explained.
If you're Greenpeace or World Wildlife Fund, you have made your views perfectly clear through massive advertising campaigns. To now put yourself in a position where you also determine the information that is used by you, so on, is not very healthy.
Okay, but we've tried to get a balance here. You asked the question, and my colleague, I'll try to get a balance here today. And we've picked, 6 people that we think reflect a balanced view of what's happening. We didn't sort of dig into your activism of the past or anything, and if we did, I don't think that would exclude you from coming here today. That's the very point I'm making. I think it's nice to get a colourful array of people with colourful backgrounds.
Yes, but if the gentleman who is leading the chapter of Bayer 5 is still advising the Environmental Defence Fund, that's not in his background. That is his current
Well, I don't have the knowledge of who is on the groups in the thing and who's what, but I would just say that we need a good mix. You mentioned in your opening remarks today about us being calm and collective about this. I've tried to be calm and collective, but it's difficult when people come up with remarks like you saying, and say just because you don't agree with certain activists or their activism, that somehow they don't contribute in an important way to the debate.
Well, I'm sorry. I think I've done a poor job of explaining myself. I think if you want the public to have confidence in the conclusions of an expert body, that expert body should go to some length to appear objective. Justice must not only be done, it must be seen to be done. And that is not a concern that the IPCC displays at this point.
I think I've exhausted this point, but one point, Professor. Again, I've been listening. It's a great session for listening and reflecting in these type of inquiries. Didn't you say in the beginning that even if man was 51% responsible, that we shouldn't worry? Did you make that remark? Because I don't want to
said it was consistent with not worrying.
Sorry?
That is to say, if you said that the sensitivity to a doubling of CO2 was 0.6
Just
degrees,
in that context, okay.
It would still be reasonably compatible with that statement.
Do you go further to say we shouldn't do anything about it?
I'm saying at this point, we not only don't know what to do about it, but almost everything proposed would have very certain consequences for the people and very uncertain consequences for the environment. That should be taken into account.
So what about the old cliche, doing nothing is not an option?
I don't believe that. I mean, Bill
even
Norton,
if you accept the 51% could be...
You know, exactly. Nordhaus has this book.
Sorry?
An economist at Yale, Bill Nordhaus, has a book on climate policy. And if you look carefully at that book, he estimates the cost-benefit and so on of various policies. And it's clear that there's virtually no policy that beats doing nothing for 50 years.
But in 50 years' time, if you and I are still around and we got it wrong, wouldn't there be a little bit of guilt?
No, because the other policies wouldn't have done much to avoid it.
Okay. We're not going to agree on that. But
I
wanted to clear your
that's easy to show. That's the
I know,
point.
but
That's what's disturbing.
policymakers would be criticised for following that.
They may
logic.
be criticised, but as you say, we'll all be dead by then.
Not all of us.
And no, but the point is...
No, it's a serious... I mean,
the issue of doing something...
It is about future generations as well.
But it's also doing something, if it's purely symbolic, to show you did something, maybe is something that you should be more responsible than doing.
Just to be clear, your suggestion of bias amongst the authors wasn't about Working Group 1, it was about Working Group 3, is that right? 2. Okay, get that clear. Right. Okay. Well, thank you very much for coming in. It's been a very interesting session.
Portcullis House, the Grimond Room.